Hey everybody, my name is Rahul Singh, and I'm a platform architect at the Anand Corporation. Today I'll be talking to you about the Cassandra Toolkit, which is my list of tools for Cassandra Titans. This is a toolkit that I wish I had been given when I first started off with Cassandra about 8 years ago. I work for a company that creates and manages global data platforms with Cassandra, Spark, and Kafka. If you would like to work with us, we're hiring. Please check us out on the internet at www.not.us, and would love to talk and have you show us something that we don't know. We architect things, meaning we create and manage, design, or make in computing global platforms. I don't know if you can see my t-shirt, but that's my t-shirt. I'm an architect. What do we love? We love scalable, fast data and how to do it. We use open source technologies and are cloud neutral, but we also use commercial technologies because they make our lives a lot easier. And we support open source and commercial source and cloud. What are those? Well, that's what we're going to actually talk about today, are to help you identify some of these icons if you don't know what they are. A lot of these tools you may be familiar with, but you may not be familiar with how to use them with Cassandra. And today I hope to give you the master list of tools that if you learn them all, you will be a master of Cassandra, a Titan. So you're a day-to-day engineer or an operator, an architect, right? What should you get started with? Well, my list includes these 3 tools to start with. Mobax Term is, on Windows at least, it's probably the best tool for working with Cassandra, and I'll show you why. dbeaver, probably the most widely, at least I've seen in my profession, most widely used with Cassandra in a lot of different places to kind of have a GUI interface to query Cassandra and make modifications to schemas and things like that. But the one that I don't see too many people use, but I wish they did, it's a tool called Hackalade. And Hackalade is a general NoSQL data modeling tool, but it has specialization on Cassandra. The main takeaways is, if you use Mobax Term, you can manage many sets of servers. Sometimes you need like a quick go-to to look at all your servers and quickly jump in and do a query. That's where dbeaver helps. And tools like Hackalade aren't just good for designing a schema, they can also produce good documents. This is Mobax Term in action. Just imagine if you have to get into 10 servers and run the same exact command, or like a tail command, right? You'll see later on that if you're using the right automation tools, you don't need to do this, but every now and then you need to run the same command on all the machines. Well, Mobax Term is the tool for you. dbeaver, as I mentioned, has a driver for Cassandra. It lets you see not only queried data, but also tracing information. And as you can imagine, you can have connections to all the different Cassandra clusters and key spaces and tables that you might want. And then finally, Hackalade. Hackalade, as I mentioned, has a way to design Cassandra tables and key spaces. But the cool thing is that it can also help you design APIs, like REST APIs or Avro schemas. So I would highly recommend you take a look at it if you're an architect. Data operations. This is when we have to get data in, get data out, move it around, take it to a party. Data operations is a big part of data platform management. How do you get data in? How do you get data out? Well, for the longest time, DS Bulk was not openly available to people. Now it's available. It works with Cassandra, DataStax. And it helps you get data in and out of Cassandra using CSV or the JSON format. And I'll show you a little trick on how to take data out, do some transformation, and get data in, all using dsBulk and a few Unix commands. There's another tool called Spark Migrator or Scala Migrator. It's by the guys that make Scala, but it totally works for Cassandra to Cassandra, moving data from one Cassandra cluster to the other Cassandra cluster. Like if you want to move a table from one Cassandra cluster to another Cassandra cluster, or if you want to move one table from one schema to another schema, it's really cool and it's all configurable, right? And then finally, Spark Shell. At some point, if you're a Cassandra DBA, Cassandra developer, architect, you probably want to have Spark and Spark Shell at your disposal, because in lieu of not being able to do, update all of these records where XYZ filtration criteria meets or XYZ where clause, Spark allows you to do that. It's the closest thing that you're going to have in Cassandra. Here's an example of using dsBulk to get data out, and then to use sed and awk to make some transformations on the data, and then use dsBulk to load it into another cluster. Isn't that cool? I think it's pretty cool. Airflow and Jenkins. Airflow, I think a lot of people have heard about at this point. Jenkins, I'm sure you have come across Jenkins in your job. If you have not, I don't know why, because Jenkins has been around for a long time. Normally, people think about Jenkins for DevOps in the sense of source code, continuous integration, continuous delivery of source code, artifacts. Although these days it has so many plugins, and because it's just a scheduling tool, it runs things and it has dependencies on what runs after another. You can actually use it to do large-scale data operations, like extract this, make sure it's valid, transform this, make sure it's valid, load it here, right? But Airflow is even better. Airflow is specially built for managing data and moving data. It's not really for moving data, it's for running the jobs that move the data, running the jobs that transform the data. Airflow has a simple language, which is built on top of Python to describe what to do. And there's an article that you can find, but basically you can use Airflow to run a Spark job to get that data into Cassandra. You can then use another operator in Airflow to check some information in Cassandra. And then if it's valid or not, depending on that, you can run another Spark job or run a Python task. Normally, when people go from cron jobs to Airflow, it's because they have a complex data pipeline. And look at it. If you're in the data world, you should really know how to use Airflow. All right. Well, what if you're an operator? You gotta back up, restore, repair. Yeah. It's not always easy to back up and restore with Cassandra. It's available as part of the tool, but you really need to have your stuff together. And if you don't have the right tools, you could be in a bag of hurt, as Steve Jobs used to say. Well, thanks to the wonderful people at The Last Pickle, who are now at DataStax, and Spotify, there are two tools that can help you tremendously. Cassandra Reaper, it's a graphical user interface for managing backups and restorations to and from the cloud. Cassandra Reaper is a GUI for managing repairs. I'm sorry about that, repairs. And Cassandra Medusa is for managing backup and restores from the cloud. Why? Because, running cron jobs for your repairs or running cron jobs for your backups, it's just not sustainable, especially if you have lots and lots and lots of servers. It's eventually you're going to make a mistake, right? And you have to keep track of which cron task is running on which server. If you use something like Reaper, it'll do it for you. It'll keep track of all the ranges. If you're using Medusa, it can save data from one cluster topology and then use that backup to then restore it to another cluster topology magically. Reaper, it's got a great interface. You can even get a snapshot of how the cluster is doing. There's different ways to install Cassandra Reaper. You can do it with an embedded database, but if you want to be managing multiple clusters, which you can, and multiple schedules of repair, I recommend that you run it on top of Cassandra or a database like Postgres. As I mentioned, Medusa can be used to take a cluster, back up, and then restore it. You can also take data, back it up to the local machine, and then restore it. A lot of cool options for free, right? Everything I'm showing you here, by the way, in this presentation is open source and free. And if it's not open source, it's free. Understand. Let's always try to understand what's going on. A lot of times things don't work and people complain. Cassandra's not working. Something's wrong with Cassandra. And my answer is there's nothing wrong with Cassandra. There's something wrong with your code. There's something wrong with your data model. And 99.99% of the time, I'm right. And that's because when I dig deeper, I find little things and I show that, hey, there's something off with your data model. Or, hey, looks like your code is doing a really weird anti-pattern here. How do we figure that out? Later on, we will talk about using log analyzers that are constantly ingesting your logs. But many times when I go into a situation, they don't have Elk, they don't have Splunk, they don't have Datadog. There's just stuff hitting the fan, right? So what do? Well, I use a variety of ways to grab all the logs and all of the configs. Thankfully, these days, DataStax is open source. Their diagnostic collection tool. You run it against your cluster, it grabs everything for you, brings it into one, tar file. And my team and I have come up with a few tools to basically parse that offline and put it into Elk. Otherwise, if you don't do it properly, all the data comes in the same day because you get the files in one big tarple. And the other tool that we've just developed is called Table Analyzer, and you'll see what that's for. But basically, it's to help us understand what's happening to the data by studying this table stats in a different way. You can get all of the table stats metrics on a time series, and you'll see something. But if you look at it in a different way, you'll see something else. So ingesting all the data into Elk, right? You can see things like what's happening at this time. There was no log entries, but all of a sudden we got a bunch of log entries. What happened here, right? So you can zoom in and look at the warning messages, the info messages, etc., across all the servers. And then you can do things like show me all of the logs organized by the level of the log. Warning, info, debug, error, right? How many errors are happening? How many debug statements are happening across the cluster? Or you could even say, show me across the cluster all of the log entries by nodes, right? So you can see if one node is creating a lot more traffic in the logs than another one is. And then in this case, we're looking at the different Java classes, essentially, that make up Cassandra, or DataStax. In this case, it's DataStax, to show us what's happening. How frequent are these tasks happening across these threads? Why is this useful? Well, if something isn't behaving properly, it's because these things are not in balance. In a distributed system, things should be in balance. The errors happen. They should be across the cluster. If the warnings are happening, they should be happening across the cluster. Then we know something is wrong systemically. But if they're only happening on a few servers, we know that It's not the whole cluster. Cassandra, nothing's wrong with Cassandra. There's maybe something wrong with that node, right? So log analysis is a powerful thing. And many times you don't have access to log analysis. Using this tool to grab it, Diagnostic Collection Toolkit, and using Cassandra Analyzer, you can get it up and running on your local machine. And then Table Analyzer can take the same output from Diagnostics Collection and show everything to you in one Excel file with conditional formatting. Well, how and why do we use this? Well, the way we use it is we take the table stats, which is a key value output from Node tool. We make it into a CSV, and then we pivot it, and we make it into an Excel. It's really not that complicated. And then we apply conditional formatting. And when we apply conditional formatting, we can see patterns. So for example, and you can sort, right? So I sorted everything with compacted partition maximum bytes, mean bytes. And I noticed that there's one table on one node where the partitions are a little bit larger than basically the rest of the cluster, the rest of the nodes. What's happening here, right? Another thing that we can notice here is when I filtered by just one table, one key space, is that in this cluster of 6 servers, only 3 servers have data. And it's all in one key, one partition, and the rest of them don't have any data. What's happening there? Well, that's a data skew, and I'm not going to get too much into it, but these type of insights, it's really hard to get even with something like Elk, or even if you have Op Center, you really can't figure this stuff out. Now, in an ideal world, you would have something like Op Center and a good log analyzer. And if you don't, actually, these days with Prometheus and Grafana, I would say it's a little bit better actually to use Prometheus and Grafana. So there's a tool called Metrics Collector for Apache Cassandra, which actually has everything in one package for you. The collector for Cassandra to get it into Prometheus, and the Grafana dashboards for you to make it so you don't have to recreate the dashboards, basically, right? I would say that that's a no-brainer, right? It's open source, you can just grab it. Now, if you are going beyond and you're going to start hosting hundreds of thousands of nodes, and you want to keep those metrics somewhere to visualize them. And you know, with the world of containers, which we'll talk about in a little later in today's session, you may have a lot of Cassandra nodes creating a lot of data for Prometheus. And Prometheus itself is not a highly distributed, highly available data system. So Cortex is a project which basically runs on top of Cassandra to provide a Prometheus at scale. It's pretty cool. There's about 4 other systems that provide Prometheus at scale. I picked this one because it runs on Cassandra. The rest of them, whatever. Don't worry about it. And of course, Prometheus and Grafana. I mean, these tools, they're indispensable in the cloud world today, cloud native and cloud world today, because every major system already has a collector for Prometheus, right? So why reinvent the wheel? Just put everything in Prometheus and then look at it on Grafana, because you can then correlate different events together. Wow, isn't that beautiful? That's the metrics collector for Apache Cassandra set up, getting data from Cassandra and into Prometheus, and then Grafana is showing it to you. And Cortex has been reportedly set to have done 1 trillion samples a day running on top of Cassandra. Now, I'm very objective about this. Splunk is probably one of the best log analytics tools out there, but it's also very expensive. And other tools try to come close to it. But what I figure is if you don't have Splunk, just use FileBeat, Elastic, and Kibana. it's free. And if you really don't like the licensing from Found, the company that makes all this stuff, maybe they're called Elastic, I don't know what they're calling themselves now. Amazon has something called Open Distro, which is open source in a different, they forked it and they maintain it, right? But FileBeat or Logstash helps you get data into Elasticsearch, and then Kibana helps you visualize what's in Elasticsearch. Remember I showed you there, you can use tail on there, right, to see what's happening right now on the cluster for maybe 6, maybe 8 computers, depending on how big your screen is. But eventually, you're going to have more and more nodes. That's not going to work, right? You want to see in real time as the logs are coming in. Well, this setup will help you do that. And I didn't make new screenshots for this set of tools because ideally, if you do have this coming in real time, then you can see these trends in real time, as opposed to seeing them offline. Now, let's talk about the big leagues, right? Infrastructure these days is code. And I have a favorite tool for that. Software configuration across, or let's say in our case, Cassandra, across 100 nodes without the right tools is, I don't know what word to describe it. It's just not what you do. If somebody's telling you to maintain a cluster of 60 nodes by hand, I would go work somewhere else. I would come work for not. I'm not kidding. I have had to work in scenarios where in the middle of an emergency, we had to take measures across all the nodes. And because there weren't any systems in place, it was extremely hard. So now I know better. I try to recommend people to use things like Terraform, which is infrastructure as code. Why? Because it's cloud neutral, first of all. They're providers for basically every cloud out there, including VMware, right? Including a company called Packet, which does bare metal. You can be like, Packet provider, make me a server, and somebody will give you a server at Packet, right? But it does more than that. Terraform manages the dependencies of all of the things that make up the cloud now. Because your node isn't just a node in the cloud. It's got disks attached. It's got network interfaces attached. It has security groups attached, right? So why wouldn't you just use CloudFormation or ARM on Azure or whatever Google's is? Because that's a different language for each system. Terraform is the same syntax across the systems. Now, you cannot literally say, make a computer, unless you do some work, unless you make a module. You can't just say, I want 5 computers on Google and on Amazon and on Azure using the same resource, but with the same code base, you could maintain all of those 3 clouds without having to learn 3 different languages. Atlantis is a tool to manage those Terraform state management, in the sense that planning changes to the infrastructure, applying it. If you haven't used Terraform, it's similar to Kubernetes in the sense that you have a state locally and you hit apply, and it basically applies that to the cloud. Right? And it seeks the difference between and says, what do I need to do? And with Atlantis, you can just do that with merges to GitHub. It's pretty cool. TerraGrunt is a tool to allow you to have the same code base and manage different environment variables in an innovative way in relationship to Terraform. You can do that without TerraGrunt, but then what you have to do is basically have 3 different directories with your different states. With TerraGrunt, you would just have one core directory, one core code base, and your environment variables will be managed with TerraGrunt. And one last thing about Terraform is that they have providers for you to store the state on the cloud itself. And so what that means is you could make modifications to your code locally, and it applies it to your 100-node cluster. And somebody could make a merge into Atlantis, and that gets applied. But when that gets applied, it will pull the freshest state being stored in the cloud for you. It's amazing. What does it have to do with Cassandra? Well, you need to stand up a 6-node cluster for testing tomorrow. Push a button, it'll be done in about 15 minutes. You need to scale that to 36 nodes. You go to the file, you say, I want 6. From the 6 nodes, I want 36 nodes. And it will sense that 36 nodes are not there on the cloud. It will then create them for you. And after you're done with 36 nodes, you want to bring it back to 6. You go change a variable from 36 to 6. You hit apply. Boom. All of a sudden, it comes back. And so I know you could go to the cloud console in these different clouds and do it. But to be able to do it in an auditable manner in code, you kind of have to do that with big companies. Cool things about Terraform, it will output after everything is done. It'll destroy stuff for you when you're done with it. There are third-party tools that you can see the dependencies across all of the different things. I geek out with Terraform, sorry. You can build the whole world with Terraform. Atlantis, very simple. You make changes to your code. You do a pull request. Somebody merges it. It runs Terraform plan. Somebody else merges it or hits apply, and it goes ahead and runs that against the cluster. Right. All in Git. Ansible. Oh my God. I don't know what I would do without Ansible. Ansible is by far the biggest pro tool in managing large-scale clusters. And Ansible isn't just for physical servers, right? Terraform creates, nobody does physical servers anymore. Ansible isn't just for virtual machines, right? Terraform creates your virtual machines. Ansible then is used to install stuff on there, configure it. You can also use Ansible to run ad hoc commands against your whole cluster. You can do things like rolling restart, ad hoc, or through a playbook. And there's been a GUI, a graphical user interface for Ansible for a while called Semaphore. Recently, Red Hat has actually open sourced AWX, which was their commercial tool, Ansible Tower. But yes, MobX term could be used. You can SSH, you can do parallel SSH, all of that. Or you can manage your environments with variables. And the same exact playbooks get executed consistently across your clusters, regardless of what size they are. Right? Isn't that neat? These are some third-party tools to kind of show you your playbook and all the tasks that make up a playbook. You can do things like install packages, add users, set directory permissions across many machines, right? Sometimes Cassandra permissions go off. Fix permissions. Boom. It'll go through each node and it'll fix the permissions on it. Right? Ansible Semaphore's got a really cool interface. So if you don't like the command line, you can use Semaphore. AWX recently out there has pretty good user management. It also has the concept of workflows, which is like a pipeline of tasks. And then finally, the bleeding edge, containers. I don't know if this is the bleeding edge anymore. At least for Cassandra, it's bleeding edge. Not a lot of people are doing Cassandra on containers or Kubernetes. But here are some tools to pick up for what's coming and what's happening. And if you want to be on the latest and greatest. So Docker is useful for people that don't use Docker in production, because you can have a Docker composition with Cassandra and Kafka and Spark and the code that is your company's code come up in a person's virtual machine or their laptop, self-contained. Developers can work with the whole environment in one computer. Now, with Kubernetes as part of Docker for a toolbox for Windows or Docker for Windows, you can also have a full Kubernetes application running on your computer. Well, if you want to run something on Kubernetes, you have to have an image for it, an OCI compliant image for it. Docker is the easiest one. And there's a Cassandra container. It's not really the official Apache one, but it's pretty good. Or you can make your own, right? But customizing a Docker container is not that hard. You can just say, take this one from Cassandra and add to it these configurations, or mount this configuration file, and use that in your application in Docker Compose or in Kubernetes. Now, if we're going to be doing Cassandra on Kubernetes, and Cassandra has been one of the use cases on Kubernetes for a long time. If you go to kubernetes.io and you look up Cassandra, there's a great article on how to use stateful sets to make Cassandra work on Kubernetes. But, I shouldn't say but, I should say and, there's a better way to do it with Cassandra. So I'm involved with the Cassandra Kubernetes special interest group. I've written a few articles on the Apache Cassandra blog that you can check out about the progress of this group. There were 5 different ways to run Cassandra on Kubernetes. And 2 of the main players, DataStax and Iran Telecom, came together and have started to work on the Cassandra operator. And then DataStax took that operator, added to it metrics collector for Apache Cassandra, added to it things like Prometheus and Grafana, which are part of MCAC, and have made it easy to run Cassandra the right way, using the right operator out of the box. It's actually a Helm chart, if you know what Helm is. Helm chart is a way to package different parts of a Kubernetes deployment. And wow, oh, and it has Reaper and it has Medusa, right? All of that's there. So why would you, go brew your own beer when you can just go around the corner to the bar, right? It's fairly new, but if you want to play with Cassandra on Kubernetes, you should check it out. And my favorite, not just because I like the movie Stargate and I've watched the series, I've always sought an easy way to get developers started on Cassandra. I've always sought that. And there were several tools that have come and gone, things like Apache User Grid. There's another one called RESTbase, as a way to give you a REST interface to Cassandra. Even the Dino emulators that are out there on top of Cassandra, those kind of do it. But Stargate is more than that. Stargate is an ecosystem of APIs that are basically API extensions to access Cassandra. And I'm not going to get into its deep architecture, but Stargate can also run on Kubernetes. So if you run Stargate and on Cassandra, you basically have a scalable data platform that can infinitely grow, because Cassandra scales, Kubernetes scales, and the way that Stargate is built, it will also scale, right? So containers of the future. You should start playing with this stuff now, right? And it's just easier for people to test out stuff than virtual machines, because they take a while to kind of come up and get installed and all that. Cassandra, just imagine you push a button and you get all the cool, well, not all, but you get a lot of the cool stuff that we've already talked about, right? Reaper, Medusa, Prometheus, Grafana. It's all running on whatever cloud you want, because it's Kubernetes, and Kubernetes runs everywhere, basically. Stargate, the API layer for Cassandra, right, runs on top of Cassandra and currently supports REST, JSON, GraphQL, and CQL. You can talk to these nodes using CQL. And what's coming, and actually it's already out there, I've seen the commits and issues being resolved on the GitHub, gRPC, which is general or generic RPC, also commonly misnamed Google RPC. using protobuf, amazing technology. And then this one I'm also looking forward to. I don't think it's there yet, which is events, being able to send data via events to Cassandra and get events out of Cassandra. So now you know what are those. Terraform, Atlantis, TerraGrunt, Ansible, Semaphore, AWX. This layer right here, basically large-scale operations. Grafana, Prometheus, Cortex, kind of your vision into, the metrics. dbeaver, Hackblade, and Movex term, your day-to-day. Beats, Elastic, Kibana, and Open Distro Elasticsearch for your Elk stack. It's called Elk, but nobody uses Logstash anymore. Jenkins and Airflow for data operations. And then for the next generation of Cassandra, Docker, Kubernetes, Cassandra, and Stargate. And of course, Spark. I mean, Spark, I should say Spark is something you should just use. It works really well with Cassandra. And then the ones I didn't have actual icons for, I just kind of copied and pasted the GitHub avatar that it creates. But DS Bulk, Cassandra Medusa, Cassandra Vision, Cassandra Reaper, and the diagnostics collection tool. That's not even all the tools available, but those are the ones that, if you're using these, you're definitely a Titan of Cassandra. Well, we won't have time for questions today because it's pre-recorded, and I apologize. But thank you so much. Thank you so much for hearing me speak about something that I love Cassandra. But what I love more than Cassandra are people like you using the right tools to get the job done so that you're smarter, faster, and better. That's why I put this together. I want all of you to have a better experience becoming sweet and great at Cassandra than because it took me a while to get all this stuff together, right? Thanks, everybody. Have a wonderful rest of the day. And thank you, DataStax, for bringing us all together. Have a good day. Bye-bye.
Okay, here I am. Hello, everybody. Yeah, I hope you can hear me well. Please give me a thumbs up if you can. So, can you hear me? I'm seeing myself on the screen. I hope the sound is good. Is the sound good? Okay, okay. Very good. You can hear me. So, hi everybody again. Welcome. This is the So yeah, I understand there has been a bit of a mess up with the naming of the rooms, but I assure you this is the room for this is the room for the talks. Indeed, there has been right now Rahul's talk about the Cassandra toolkit. Now I'm here to present you the talk about the Cassandra certification, which is going to be 1 hour more or less, and it will feature a bit of explanations and a live demo of some questions, as you would find in a Cassandra certification exam. So it's an excuse to study a bit and exercise a bit your knowledge of Cassandra, and it will be interactive. So let me start. Let me start here. First thing I would like to, let me get the link. I would like to draw your attention to this here. This GitHub repo, I will paste the link. I will paste the link here on the YouTube chat. This is the repository containing slides about what I'm talking about today. It will also contain some more instructions, practical hints and tips to prepare and go to the exam. And it will contain also practice questions, a bit more practice questions than those we will see today, because that comes from a longer talk. And so you will find even more questions there to exercise. Okay, so who am I? I'm Stefano. I'm a developer advocate at DataStax. And these are my contacts. You are welcome to reach me out on YouTube, on LinkedIn or Twitter if you want. Okay. So let's speak about Cassandra certifications. We will see which are the available certifications for to get a certified Apache Cassandra. What are the resources available to prepare for getting the certification? And then we will see how you get the certification in practice. And the rest of the talk, more or less half an hour, will be an interactive session with questions similar to those of the exam, and you will be able to participate. Okay, so which certification and what resources? First thing I have to say is that the Cassandra, the Apache Cassandra certification is recognized, is well recognized on the job market, and it is verifiable certification coming from an exam done with checks, so it's something taken seriously, and it is a very good way to make your resume stand out and to prove with a piece of paper that you are an expert on a topic that is in more demand than offer. Still, that's a good point. So at the moment, there is much demand for qualified people able to operate and work with Cassandra. That's an important point. And by the way, in the landscape of NoSQL database development and administration, it is Cassandra, working with Cassandra, usually there are some statistics. I will show you some websites. Working with Cassandra helps you landing a well-paid job. There are numbers back in my claim here. Okay, so which certification should you get? Well, let's see. There are various certifications concerning Cassandra, and today I'll concentrate on the two most important, if you want, most important ones, the entry point ones, which are the one for administrators and the one for developers. So this is a small flow chart that explains how are the two study learning path organized. So there are two curriculum made by several courses, and most of them are shared by the two certifications. And then you will have to choose a specialization. So there is a course, an introductory course to Cassandra, followed by a course on the foundations, which more or less covers, and obviously goes much more in deep detail, covers what is being described by Alex in the other room, so the fundamentals of Cassandra. At this point, you will have to choose between two different paths. You can choose a course focused on operations, which will lead you to the administrator certification, the one you see here on the left, and it is designed for database administrators, DevOps engineers, site reliability engineers, and it is concerned about operations, setup, configuration, management, and so on. The other choice is to go for the developer direction. So if you are more an application developer or a data architect, if you design database and so on, you might want to go for the other course, which is data modeling, which will then open the way to getting the certification by passing the exam. Which one should you choose? Well, that depends on your career, obviously, but nothing prevents you from thinking of trying both and getting certification on both. So you'll be, the guy who knows Cassandra head to tail. And this is not a bad thing, especially in a small company where you might end up having to, know all of it and maybe teach to your company how Cassandra works. Okay, so what are the resources available for preparing for the certification? Well, sorry. First, there is a website, datastax.com dev certifications, which is your entry point to actually go and take the exam. I will show you that very soon, very briefly. Then you want to start from the GitHub repository I written already in the chat, and I will put it there again just as a reference, because from that point you can go to all other links. So it's very important if you want to bookmark it. So this repository contains slides, practice questions, and other important tips. And then there is the actual learning material. So there is a good deal of training on academy.datastax.com. That is the academy, because all of these courses are provided for free to you by DataStax. So the courses and the teaching material is about Apache Cassandra, the open source product. But the content is sponsored by DataStax, who obviously it is in DataStax interest that as many developers as possible know and use Apache Cassandra. So it is our interest and your interest match, because it is we want you to be good at Cassandra. So that's why DataStax sponsor all of these materials. So there is on the academy datastax.com, you find the courses. There are lessons, exercises, and so on. I will show them to you quickly later. Then other very important resources are the forum. So community.datastax.com is where you can ask questions concerning Cassandra. It is a bit like Stack Overflow, right? But it's focused on Cassandra. And well, many fine and knowledgeable people from DataStax, and not only from DataStax, are patrol the website and answer all of your questions. So it's a very useful resource, actually, especially when you start getting your hands dirty with the database and you start banging your head against a problem, or you have a doubt. Go there. There are the best Cassandra experts in the world probably are there to answer you. So don't forget, we also have a Discord channel if you want to keep in contact with us on the long term. If you want to carry on a discussion, that's a long-term kind of chat, probably much better than the YouTube chat, because when this stream is over, the YouTube chat is disappeared, while the Discord will be there. So you are invited, reach us. There's a huge community, and we are always there for you. Don't forget, another very important thing is that besides the academy, we also have on our website a lot of hands-on exercises. So they are practice scenarios with some lesson and scenarios. You can go there, you do all in the browser, you work on a real Cassandra installation, and you do exercises guided by the interface. And it is a very good way to learn by doing. Okay, so let's see. What do you do in practice to get your certification? What do you do? First, you go to the website I told you before, so datastax.com dev certifications, and there you will see there are a bit of information about how the exam is done. There are some statistics, some information about how and why is the certification is important. But most important, take note of how the exam is done, because the exams are done online in your browser, but they are proctored, which means that there will be somebody looking at you on your webcam and making sure you do the exam, you follow the rules, you don't cheat. So you can't have a piece of paper here with your notes, you can't have a phone, you can't leave the desk has to be clean. So there are a few rules. You are required to have your own ID document and show it to the webcam so they can check your identity. So there are a few things. Don't forget to go to the bathroom before starting the exam, as you will not be able, obviously, to leave the desk. Nobody can enter and speak to you, and there are a few rules. I have to say the exam is well done, is very strictly checked, but it is not as patrolled as AWS. I mean, there is an important difference. The exam does not need to be booked in advance. So let's say it's Saturday night and you feel like, wow, I'm ready. I want to do the certification exam. You go there, you click, and in a few minutes you are in contact with a proctor. You will communicate through an online chat in your browser, and in a few minutes you start doing the exam. Now, the exam is 1 hour and a half, so 90 minutes, and it is 60 questions, whatever the exam. So whether it's administrator or developer, it's 60 questions, 90 minutes. That does not mean that you have 1 minute and a half per question, because you can go back and forth. You can leave a question for later. You can do another question very quick, because there are many questions that, if you are prepared, are quick to answer. Some other might require you some thinking. So you can mark questions as to review later and go back and forth and take your time. And I have to say, if you are prepared, 90 minutes are more than enough to do it comfortably. So it's not a race, a time race, let's say. Okay, so this is it for how the exam is done. Let's say you have made your mind, and you know, okay, I want to take the developer certification exam. Okay, so you have chosen your path. Then you go to the academy. You go to DataStax Academy, that is academy.datastax.com. You sign up, and all the courses will be available to you for free. So you enroll in a course, or more precisely, you enroll to a learning path, which is a group of courses, as you saw in the flow chart before, and you do step by step all lessons, and you follow through the course until completion. By the way, the website keeps track of your progress, so it helps you, keeping a bookmark on where you are in the course. And the courses are a mixture of video lessons, small quizzes, and exercises. So it's a good mixture that is well done to keep you engaged and help you, commit to memory what you are learning. So let's say you finished your material, you finished your courses on the academy. At this point, you're ready to take the exam. So what do you do to take the exam? Now, I'm going to say something that might scare you off, but please don't. The exam has a cost, because we rely on an independent company to do the proctoring of the exam. So it has a cost, and the cost is $145. But there are many ways to do it for free. Indeed, it is our interest that as many people as possible work and know and love Apache Cassandra. So there are various ways to get a free voucher to take the certification exam. For example, you can complete, if you complete your learning path, all 3 courses on the academy, you can contact academy.datastax.com and you will get your free voucher. That's one way. The other way is you can follow one of our many workshops that we do on this YouTube channel, and we do many per week. There is a link here. I can paste the link here on. Okay, so we do several workshops every week, sometimes 2 or 3, sometimes even more, on various topics. So not only strictly databases and Cassandra, but sometimes also development, front-end development. We cover various topics of interest. You can follow one of our workshops. You can do the exercises which are there, and they usually make you create an instance, a database on our AstraDB platform, which is free, and it is a very handy way of working with a database without having to, set up everything on your machine. After the workshop, we will give instruction. You can contact us, and you will get your free voucher. There is another way today for the Cassandra Day India. Everybody who attends the event and is registered to the Cassandra Day India, you can go to this link, the tsx.io CD India-voucher. There is a feedback form that you fill, and at the end, you will be able to get your voucher. So you see, there are various ways to gain your voucher and go taking your exam for free, sponsored by DataStax. Mind that the voucher has a limited validity of 1 month or so. So before redeeming it, make sure you are more or less prepared. Another thing is that the voucher is not issued automatically. So even if you fill the form today, please give us a few days, say a week most, top a week, and you will get your voucher. So don't worry. Okay, so this is for getting the voucher. Last point, you go and take your exam. So as I said, you don't have to book ahead. You just go there and redeem the voucher when it's time to pay for the exam, and you will be able to do your exam. So let's assume you will be passing the exam. You can celebrate, and again, everything I said and all links you will find in the GitHub repository I mentioned. Another thing, so usually, how long does it take to get prepared for the exam? Well, now this is a point. If you follow the courses on the academy, that's strictly speaking, that's enough knowledge to go and take the exam successfully. And that might take, I don't know, 2 weeks or so, a couple of weeks, something like that. If you want to get a more in-depth knowledge, which is probably your goal, besides the certification itself, you might want to do additional exercises, the interactive scenarios, as I mentioned before. You might want to start reading the documentation, experimenting on your own. You can probably will come to our community, datastax.com, and start asking hairy questions and have them answered, whatever. So if you want to become a bit more knowledgeable, more than just the bare minimum, that will probably take you 1.5 months or something like that. So 6 weeks, let's say. Anyway, at some point, you feel ready and you go taking your exam. Very good. Now I would like to do a very short demo on the various parts of the websites that I mentioned, the various parts of the exam process. So let me show you first. This is what the academy looks like. You see at the bottom, you see some cards. Each one corresponds to a course. There are actually many more than I mentioned. So there are specialized courses on DataStax enterprise products. There is a course on Kafka connector and so on. In particular, the first two here are the learning paths. So you see admin learning path and developer learning path. So this is in the academy. So once you register in the academy, you will have access to those courses. Let's open the developer learning path, and you see it's made by 3 courses. I hope you can see. I make it a bit bigger. You see it's made by 3 courses. You can enroll to them, and you can look at what is in the courses. This is the third one in developer path, which is data modeling, a very important part of developing and building a database for an application. And it is, you see, the course is made by various modules, which you see there are exercises, there is a quiz, there is another video lesson, and so on. So this is a very mixed kind of content. Okay, so this is it. Now, this one DataStax.com dev certification is the page with where you go to take the exam. You see, first, okay, here you see some statistics about why and how is the certification might be useful for your career. At the end, don't forget to have a look at the exam rules and process, which is what I was telling you before. So it's a closed book exam. A live proctor will watch you. The exam area should be clear of paper, devices, and everything, and so on. So the rules that I already touched. Okay. So let's say you feel ready and you want to take the exam. Very good. You click here, take an exam, and you will get to a registration page. So, okay, let's say you register. I am already registered, so I can show you directly this part here. Don't forget, so here you see, this is now the platform that handles the exam and the proctoring. So this is not on DataStax website anymore. This is on Metal platform. So you logged in to take the exam, and here you are, and you're ready to take your exam. You see there are various options available. Let's say you want to do the administrator. Okay, so before hopping to the exam, which is as all other 60 questions, 90 minutes. Oh, sorry. Before hopping to actually take the exam, you see there is a very important button here that makes you that makes a system requirements check on your machine, because you need a compatible machine, which means most browsers, but you can't have a second monitor. You need a webcam and so on. So this button brings you to a page where you can do some so a page that tests for your system. So it asks to share the screen and stuff. So now I'm closing because I actually do have a second monitor, so the check would fail. But let's say do this check. After that, you can take the exam. You see here a make payment tooltip. Don't be scared because you have your voucher ready. You click make payment. Are you sure you want to take the exam? Yes, make payment. Now, here would be the time to pay, but you see there is, I hope you can see here, it says, have a coupon code? Yes, I do. So you enter your coupon code and that is now paid for you. So there's no actual paying as long as you have a voucher, but you have seen there are various ways to get one. Okay, so this is more or less it for the demo part. I can go back to the slides. And now for the interactive question. So, okay, practice questions. So for this part of the talk, I will ask you to connect to menti.com with your phone. And I will also do that so I can track the progress. I will ask you to connect to menti.com and enter the code 82096024. And when you're ready, please. Oh, I have to start this before, sorry. Okay, now you should be able to connect. Okay, please give me a thumbs up as you come in. Okay, I see people joining, so keep joining. So we will see 10 questions taken similar to those one might see in the exam. We will take 1.5 minutes per question, and we will discuss shortly the answers. So this is not a competition. Indeed, there is no timing. Take your time to answer. You have 1.5 minutes for question. This is not the same in the exam. In the exam, you can manage your 90 minutes as you want. But now here we want to, we have to proceed. So people are coming, very good. I have to switch back and forth between the slides and the Menti, but don't worry, we will make it. because the questions are more complicated and they would not fit the Menti screen, but still I have to collect the data. Okay, can I paste the code? Sure. Go to menti.com and enter code 82096024. Okay. Okay. So let's give another minute for people to join. So you will be able to give answers to every question. Then at the end, you will be able to assess whether you are ready to take the exam already, whether you are prepared or not, or you will go to academy and study more. Okay, I think we can start now. Let's start. Ready. So these are not timed questions. So question one. I'll enter. We will start and then we will go to the question itself. Okay. So question one. See, consider this statement. There's a create table followed by a series of insert statements. Now, how many rows will the roller coaster table have after executing all the SQL statements? It will have no rows, 2 rows, 3 rows, or 4 rows. So does it work? Yes, should be working. Are you able to give answers? No, indeed. That's what I thought. Yes, yes. Okay, you're able to give answers. Very good. Very good. Okay. So it's my Menti that is somehow went strange. So think a bit about the table, how the table is made. Yeah. Sorry, I will stay on the question screen as long as we can. Sorry, yes. So have a look at the table, the structure, and look at the values inserted into the insert, and think carefully what. So how many rows will there be? Okay, we have the answer. Many of you answered C, and the answer is correct. Let's see why. So you see, this table has a single column in the primary key, name. And this column is also the partition key, by the way. But what's important is that only name is part of the primary key. So the first insert, Millennium Force, is different from the second, Formula Rossa, is different from the third, Steel Dragon. So we have 3 different rows at this point. But the fourth insert is, again, Millennium Force. So this is actually an upsert, an overwrite. And we end up with 3 rows. Okay, so only 3 rows are created. Now let me go to question number 2. Okay. So question number 2. Again, there's a SQL statement, create table something, followed by 4 insert statements. You see the values, you see the table, how it is structured. But this time the question is, what is the result of executing all the statements? A table with 1 partition, a table with 2 partitions, a table with 3 partitions, or a table with 4 partitions? So think of the table structure again. Look at the values that are inserted. Try to imagine in your mind how the table is stored and partitioned. I have to quickly go and have a look. We have 30 seconds more to go. Please don't give the answer in the YouTube chat because you might spoil the reasoning for other players. whether it is right or wrong. Okay, let's have a look. We have 10 seconds more to go. And the result is 3, 2, 1, time's up. Okay, so somebody answered 3, A, B, C, I mean, and many of you answered 12. So 12 of you answered D, sorry. What is D? D is the right answer. So this table has actually ends up with having 4 partitions. Let's see why. Because you see, this table has a primary key that is made by artist and title, which are both in the partition key. So this is a table where every column in the primary key is also the partition key, as is denoted by this double bracket, is a table where every partition is by definition made by a single row. So if I have 4 rows, I have 4 partitions. And this is the case because every different pair of artist title makes for a different partition. And here we have the Beatles yesterday, the Beatles Let It Be, which is different because even just the title different means 2 different rows and also 2 different partitions. Then there is Abba Fernando, which is absolutely different. And Frank Sinatra Yesterday also is different. So what counts is the full tuple artist title. And there are 4 different values here. So it's 4 different partitions. So congratulations to those who answered correctly. Let's go forward. Question 3. Question 3. Now, you see there is SQL statement that creates a table. And then there are 4 possible queries that I might want to run on this table. Which one will run? So look at the table structure and try to think what is a query that might actually run properly on such a table. So select from cars where make equal Ford, select from cars where year and color, select from cars where make, model, and year, or select from cars where make, model, and color. So I can tell you that only one of those will run with such a table. By the way, the exam is all closed choice questions, so that there is a set of answers to choose from. And in case there are multiple choice, it is explicitly said in the question, and it is also said how many correct answers are there. We don't want you to, guess, try to guess with a doubt. So there are 25 seconds to go. Think of the table, of the structure, think of the various constraints you have on the where clause, and let's see. And time's up. The answer, as many of you correctly said, is C. Yes, very good. So let's see. Why? Well, let's look at this table. This table has a primary key that is made by 4 fields. 2 of them are in the primary key, in the partition key, sorry. So we sure have to specify those 2 fields. So a where clause has to specify with equal sign both make and model because they are in the partition key. So answers A and B will not work for sure. Now, what is the difference between answer C and answer D? Well, the point is that besides specifying the partition key, a where clause might legally specify clustering columns values, but it has to give them in the order. So if it specifies a clustering column, it also has to put a where clause condition on the previous ones in the list. So you see, we have year followed by color. That means that we can specify year equals something, or year and color equal, but we can't specify simply color, skipping year. That is not correct. That is not working, because if you think of the underlying storage model, that would involve a hopping way of retrieving data within the partition, which is what Cassandra does not want to do. So that's why the correct answer is C. You see, make equal Ford, model equal Mustang, and year equal 1969. Okay, but congratulations, many of you thought of this and got it right. Let me go forward. Question number 4. Okay, so here we have a bunch of statements, some create table followed by a batch containing 2 inserts. And the question is, what is a valid statement about this batch? So what can be said of this batch? It is a single partition and can be applied. It is a single partition batch, but it cannot be applied. It is a multi-partition batch that can be applied, or it is a multi-partition batch, but it cannot be applied. So this question is about batches. And think a bit, how are the tables made and what kind of statements, of insert statements, are in the batch. So the questions that we are seeing today come from the common part of the 2 study programs. So they are questions that you might encounter both in the administrator and the developer examinations. While there are also questions obviously specific, there will be today no time to go into them, but you can find them on the GitHub repository. So please go ahead and have a look. There are 10 seconds left. So what can be said of this batch? Let's see. 3, 2, 1, time's up. Okay, so the right answer, as many of you guessed, is C. This is a multi-partition batch and it can be applied. So let's see why. It is a multi-partition batch for a very simple reason. The inserts act on 2 different tables. So if it's 2 different tables, you see employees and employees by department. If it's 2 different tables, it's for sure 2 different partitions. So no question there. So it is a multi-partition batch. And it can be applied. There's no problem. They don't walk on each other's feet. Somebody asked where to give you the answer. Join menti.com and paste the code. I have to copy the code here. I don't know if you can join at this point. Probably you can, but in doubt, I will put it here. But anyway, don't worry if you don't join Menti. I mean, this is an exercise for you to, to gauge your knowledge of Cassandra. So don't worry. You can also follow along, no problem. There are no prizes in this quiz. There is no timing, there are no prizes. If you want to do a quiz on Cassandra with prizes, please, after my talk, in the other room, there will be a half-an-hour quiz with questions on Cassandra and prizes to the winners. So there we will have to be fast in answering. Okay, so back to this question. It can be applied because it's 2 simple inserts. They work on different partitions, on different tables, no problem. What kind of condition would make a batch non-applicable? Well, first, if you mix counter columns and non-counter columns in the same batch, then this is an illegal batch because counters work in a different way on architecture-wise, and they cannot be mixed in a single batch. So that could not be applied. Another way is if you have running fast. Another way is that if you have lightweight transactions in a logged batch, in particular, so a batch that works on multi-partition, that is not allowed as well. Okay, well, this is not a problem. This batch is absolutely fine. Okay, so let's move to question number 5. Question number 5. Get ready to answer. Let's go to the question. So again, there is a table. There is a create table statement with, you see, the primary key part is left to you. There are 3 dots. You know that restaurant reviews are identified by name, city, and reviewer. You know that they are queried from the table with name and city. And you know that the table has multi-row partitions. And the question is, what is the primary key? Sorry. Okay. The primary key is name reviewer city, name city reviewer, name reviewer city, or reviewer name city. So think a bit about the hints that you are given, think of what the table has to accomplish, and try to come up with the right answer for the primary key. So the answer might look very similar, but if you know Cassandra, you know that there is a very big difference in such a detail as a parenthesis put here or there. And this is the subject of this question. So let's see. Let's see, we are almost there. I'm sorry I have to hop between screens, but that's the only way I can track the timing. I don't want to leave you hanging. Okay, there we go. Many of you answered the correct answer. Very good. Congratulations. Let's see why. The answer is B. Why is it B? Well, first, let's look at the first hint. Restaurant reviews are identified by name, city, and reviewer. Well, that means to me that all three fields have to be in the primary key. I cannot leave anything out, and that's perfectly fine. All answers actually include all three columns, so that's not a problem. Now, look at the second hint. Restaurant reviews are retrieved from the table using name and city. What does that mean? Think of how you arrange a query in Cassandra. Since we are setting an equal sign in the where to name and city. So we will query something like select from blah, 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 where name equal something and city equals something. To me, that sounds like I cannot have reviewer before name or before city in the primary key, because otherwise I would be forced to give also a condition on reviewer. So as long as reviewer is not the last column in the list in the primary key, that's not a correct choice, which rules out A, because reviewer is in the middle, C, because reviewer is in the middle, regardless of the parentheses, and also D, where reviewer is the first. So that's the second hint already leaves us with the answer, which is B, primary key, name city, partition, and reviewer clustering column. Now, please note that the third hint is not even used in this answer. That's fine. Now, my point is that, and I draw your attention to this. Yes, B is the right answer. It works. It has name and city as partition key. Fine, because my query is compatible. But that's not the only possible choice in general. That's the only possible choice among A, B, C, D. But if you see here on the left, if I had a primary key name city reviewer with only name in the partition key, that would have been fine as an answer. Then again, it might lead to partitions that are too big. That's another problem, and that's maybe true, depends on the data. But still, it would be a right answer if it were there. So let's see. How are we doing so far? We are in the middle, and we are more or less on time. Very good. So I see three people managed to get everything right. Many other people got 4 out of 5 questions right. Very good. Go on like that. You're good to go. And let's go on. Question number 6. Question number 6, let me bring you to the question. Okay, so here we have a table definition, so a create table statement, and a select. The question is, which materialized view definition can be used to support the query? Because you see, if you look at the create table statement, where the primary key is name, it's clear that the select as it is will not work, because it imposes a where conditions on wins, and that's not primary key, so it will sure not work. Now, I want to create a materialized view to support such a query. And what is the right syntax to make my query work? So think of what you want to do, what kind of query you want to do, and think of what is the right syntax to create the proper materialized view. So let's see, 35 seconds to go. And 20 seconds. So materialized views can be a very good help, as was also mentioned this morning, this afternoon for you, sorry, during Vinay's talk. But they are to be used with knowing what you do. So here we go. Let's see. And the answer is D. Very good. That was a bit harder, I see. And indeed, it's not so, maybe materialized views are not used daily. Still, the answer is D. Well, one point is that since my query has to be, I want to query on wins, then when I arrange the new partition key, the new, primary key in the materialized view, I have to put wins first as primary key so I can query on that. And that's the point. So for sure, A and C would not work. Now, between B and D, the difference is that when I create a materialized view, I am effectively taking at most one new column and making it into the primary key. So to help me out, CQL requires me to explicitly filter out rows which have nulls in those columns, because I cannot have nulls in the primary key. So I have to explicitly add where wins is not null and name is not null. So the right answer is D and not B. Okay, so now the query would work. Let's go on. Question number 7. Secondary index. Let's see. Again, now there is a table defined by create table statement, and there is a select. Select from restaurant by city, where city equals Sydney and cuisine equals sushi. The point is that this query as it is would not work because cuisine is not in the primary key, at least. So I want to create a secondary index. So I have my create index statement that will make the query work. Now, what is the right way to create the index I need? You might remember that a big difference between materialized views and secondary indices is that materialized views are effectively a new table that is distributed according to its new partition key, while the secondary index is local and it follows the distribution given by the base table. That's one of the differences. Then there are various constraints on using either one. So 30 seconds, scarcely 30 seconds to go. You see the difference between these statements lies in what is the column or the columns in the statement, in the index creation statement. And let's see what is the answer. 3, 2, 1, time's up. Well, that is a very spread distribution. The right answer is A for one reason. You cannot create indices on more than a single column. So all other choices are not working because of how Cassandra creates secondary indices. Mind that the query still works because you see that's a very nice example of a query that is properly supported by a secondary index, because the query not only specifies cuisine, which is what the index is there for, but also specifies city. And city is the partition key of the original table. So this query will work. Not only that, but it will work efficiently because it will still have to look at a single partition, at a single node in terms of the original table. And that's good, because one of the pitfalls in using secondary indices might be to create an index in a way so that your query will then have to speak with many nodes, and that might scale very bad if you have a large cluster. Okay, so question number 8. Question number 8. So the where clause in a query, it has to reference all the fields in the partition key. It has to reference all the fields in the clustering key. It has to reference all the fields in the primary key, or it has to reference all the fields of both partition key and clustering key. So this is a question that will not require you to think so long if you know what are the terms in the question. So this is an example of the question that will make you save time to devote to more complicated questions and those that make you think of values and inserts and stuff. Let's see if the answer coming in. So when you put a where clause, do you have to specify the partition key? Do you have to specify the clustering key, or the whole primary key, or both the partition key and the clustering key? Somebody probably knows that there's a trick in these answers. A nice trick. Let's see. 10 seconds to go. 5 seconds to go. 3, 2, 1. And time's up. The answers are in. And the right answer, yeah, very good, well done, is A. Well, that's simple. The where clause must contain the fields of the partition key, and that's it, because that's already enough to specify that the query will go to a single partition, which is what makes Cassandra happy. If you want, you can specify more in the clustering key, yes, with the constraints we already saw, so they have to be given in order without skipping fields. And by the way, answers C and D, which are not right, are the same, because primary key is partition key and clustering key. So the right answer is only the partition key. Okay, let's move forward. Question number 9. Question number 9. Here there is a SQL statement made of 2 parts, a create type, and then a create table where one of the columns is of the type name. And the question is, what is the right syntax to insert a row on this table? You see, the difference is in how the literal value of name is inserted. There is a JSON-like syntax in the first answer. There is name, colon, and then some curly brackets in the second case. There are just 2 values plain there in the third case. And the fourth answer uses round brackets. So what is the right way to spell out a user-defined type in Cassandra? That's the question. 30 seconds to go. I'm sure many of you have used user-defined types. Maybe sometimes the syntax was hidden by your client drivers, because usually there are ways to, hide the underlying SQL syntax in layers that you then use. By the way, you remember that when you create a user-defined type, it will live within a key space. So it is key space specific. If you ever need a user-defined type in 2 different key spaces, you have to create it twice. So let's see. Time's up. And the answer is A. Very good. Many of you know the answer. So let's see. The point is that when you specify a literal user-defined types, you use a JSON syntax. That's it. So the second case is strange because it is name, colon, something. And if there weren't for this name colon, that would be a good the syntax for a set of text, by the way. The answer C is wrong because that is right for simply 2 columns, 2 single text columns. And answer D is wrong, but it would work if we had a column that is a tuple of text. But we have a user-defined type, so answer is A. Okay. Now, dulcis in fundo. Last question, sorry. What is the result? What does it mean? Here, look, we have a create table statement. Okay, I'm desired on the other side. Let's finish this question. We have a create table statement, and we have 2 inserts and then an update. Look at the values and try to imagine what will the select at the end find after executing everything. So you have 1 minute to figure out in your mind. You have to use the Cassandra storage engine and think of how the 2 inserts and the updates will work on your partition. Okay, 20 seconds. Ten seconds. And there we go, time's up. The answer is B. This was tricky, right? Many of you answered C. I would have said many of you would have answered also A. Now, the point is that the primary key is username email. So we have 2 rows. We have 2 rows because we have the same username, DC1234, but we have 2 different emails in the game. So for sure, we will end up with 2 different rows. Now, the point is that after the trick is that after the first 2 inserts, there is an update. The update would like to, one is tempted to think, okay, the update is going to alter the values of the row containing Gmail address. But the trick is that the nickname column is a static column. What does it, you see in the create table, you see it's a static column. What does it mean? That means that there is a single value for the whole partition. So that single update will change the nickname for the whole partition. So that's why we end up having Davy and Davy in both rows here. Okay, so that was a bit tricky. Now I'm a few minutes out of time, so we have to rush to the end, but we made it. We saw all questions. Now, very good. We have well, I'm not saying a winner, but we have somebody who would ace the exam very well. Any of you, if you did 7,000 or more, which is 70% of the answers, you would have passed the exam, because the exam is passed if you answer correctly to at least 70% of the question. So congratulations to all, and to other, study more. I hope this today has been useful to refresh or study a bit, or to have a bit of fun. I have to close now. I thank you all for the attention, and yes, look in the repository, you will find all references and you can go on with your preparation. So, okay, this is all repeated, you will find everything in the repo. I thank you all and I say goodbye. Thank you.
Hello everyone, this is Payal and I just need a confirmation. Give me a second. I hope you all can see me. Okay, hi everyone, this is Payal and I'm going to talk about tombstones. Tombstones simply explained, and when I say simply explained, I really mean it. So before digging into the tombstones, little bit about myself. My name is Payal. I'm working with Cassandra from past 5 years as a Cassandra data administrator. I have worked upon so many performance issues, migrations, and administrative tasks. So without a further ado, let's dig in. So this is the agenda for my talk today. I am going to show you how Cassandra create tombstones while deleting data, and what are the issues created by those tombstones, how we can find the presence of our tombstones, and how many tombstones types are there. And in the end, we'll be discussing how we can get rid of the existing tombstones, and there are some compaction setting to tune the tombstone. We'll be discussing that as well. And in the last, how we can avoid the tombstone issues. So let's get started. First thing first, how Cassandra delete data and create the tombstones. Cassandra treat delete as a right. In Cassandra, everything is a right. So deletes are also right. So whenever delete happens in the Cassandra, Cassandra write a special value known as the tombstone to indicate that data has been deleted. In Cassandra, deleted data is not immediately going to be disappear. The data will be purged, but after a certain amount of time, and by the time the data is going to lying on your disk. So that's it. It was easy to understand how Cassandra creates the tombstones, right? If that's it, then what is so tricky about the tombstone, and why we are discussing the tombstone here if tombstones are that simple? Tombstones are not that simple to understand because now we know delete create the tombstones in Cassandra, but there are some more reason which by which tombstones gets created in the Cassandra. First thing is setting the TTL. So we can define the TTL, we can define time to live while creating the key space table or while inserting the data. So for example, while inserting the data, I have defined the TTL of my 20 minutes. It means I'm giving Cassandra instruction that after the 20 minutes, you make my data as a tombstone. So in that way, I am inserting the tombstone into the Cassandra. Other reasons are inserting data into parts of collection, inserting null values and materialized view. How inserting data into parts of collection creates the tombstone. We have to be, first of all, we have to be very careful while dealing with the collection data type in the Cassandra. How collection, in the left hand side, you'll see this on my table, and on my local column, I have defined the collection data type, which is map. So, whenever you update or insert value in the collection data types, they are going to create the tombstones because the internal structure is something like this. Whenever we are inserting and updating the value in the Cassandra column, it asks Cassandra to do read before write, and Cassandra doesn't support read before write. So, in order to gain the performance, Cassandra is going to mark the previous data as a tombstone. So we have to be very careful with the collection data types. Here you can see, as in the left side, I have location column where data type collection map is defined. And on right side, you can see I'm just entering one value, though I have already defined two values, but I'm just entering one value. So it is going to create the tombstones. Third reason behind creating the tombstone is inserting null values. So whenever we insert a null values for any column, it is going to create cell tombstones. So here in my table movements, I'm trying to insert null value for my username column, and in right hand side you can see the deletion info. So it means when I try to insert that data, Cassandra has already inserted a tombstone for my username column because its value is null. By the way, the right hand side thing is SS table dump output. SS table dump tool is available in Cassandra to show what is the internal content of an SS table. We'll be discussing about it more down the line in this presentation. But that was the third reason how we insert the tombstones into the Cassandra. Fourth reason is materialized view. Materialized view is, if I say simply, materialized view is a kind of table on a base table. If we materialized view allow us to query the data with the help of column which are not part of the primary key. So so if we take the example in left hand side, I have created a table CC transaction, and if you see at my primary key, user ID and month is part of my primary key. User ID is my partition key, and on right hand side there's a materialized view created on the CC transaction. By the way, materialized views are automatically handled by Cassandra. They were introduced in Cassandra 3.0, I guess so. And right hand side, the materialized view is created on CC transaction table. And if you look at the last primary key, user ID and year is my partition key here, and month is my primary key here. So let's think about a scenario where I need to update the year column in my CC transaction table. Simple, right? I can go ahead and update my year column. There will be no issues. But while updating that year column, what impact it is going to create on the materialized view? Since year is a part of materialized view, I'm so sorry. Since year is a part of, my goodness, I'm so sorry again. Since year is a part of partition key here on my materialized view, it is Cassandra has to rewrite the partition again. It has to delete the previous partition. It has to rewrite the partition again. So it means whenever deletes are going to happen, we'll be inserting the tombstones. So that's how we entered the tombstone using the materialized view. So these are the ways these are the reason behind the reason behind the tombstone in the Cassandra. So now you must be thinking why we use tombstone and why this kind of concept is there if this creates a lot of issue. Actually, tombstones are needed in Cassandra. They are not an issue, and that's how distribute deletes work in the Cassandra. And there'll be the issue for you when you start seeing a lot of error warning and performance issue, and you have already start seeing those of error warning and performance issue. Then you need to do something about it. So then what are the issues Tombstone create? Consider a scenario, you are running a query. You are running a query which is going to scan lot of tombstones because you have got a lot of tombstones. So throughout the process, when that query has to scan lot of tombstone, it might create the heap pressure, and it will be adding some read latencies. And if number of the tombstone goes higher, there will be some timeout and exception you will be seeing. And in addition of that, since we have got the tombstones, they are sitting on the disk. It means they are consuming our disk space also. So those are the issues. Those are the most frequent issues seen with the tombstones. Now, how we can say that we have got the tombstones in our system? So first thing first, we need to check our logs. You might need to check your system.log. You might need to check your debug.log. So these are the parameters we have defined in Cassandra.yml, tombstone warm threshold. Mm-hmm. Is it? Okay, let me do it again. Uh, can you see it now? Okay, just a second. Hi, let me share my screen. So you have not seen even a single slide? Okay. Can you see it now? Yeah, actually it was fine. I'm sharing my entire screen, but it is why it is not sharing. Okay, just a sec. Okay. Okay. Just last try. Can you see it now? Okay. 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 Last try will do. Okay. Yes, yes, I did. Share the whole screen. Okay. I'm again tried. I'm again going to restart it, and I'll call you in a second. Okay.
Okay, little break.
I've restarted it, but you can see it now. Can you see it now? Just, just a second. Yeah. I, can you see it now? I didn't get you. What do you mean by that? Yes, I do have, but I need to transfer it to that laptop. It might take a minute or so. Okay. Okay, I'm transferring it, and I'll call you soon. Okay. Okay. Thank
Okay, sorry everyone. We have a little issue on the speaker's side with screen sharing. So we have a little 1 minute pause and we get back to you after that.
Okay.
So, hello everyone and welcome back. Looks like we are good now and we finally can start. So please once again greet Payal Kumari from PFAN, database consultant. He explains a very important thing, Tombstones. A lot of people misunderstand them and that's a big mistake to underestimate or misunderstand Tombstones. So welcome Payal, we are happy what you are with us.
Thank you, Alex. And first of all, sorry, technical glitches. Okay, I'm going here and I'll be going a little faster because I want to try to complete all the content in the given time. So without the further ado, this is Payal and I'm going to talk about Tombstone simply explained. And when I say simply, I really mean it. So before the Tombstones, little bit about me. I am Payal, working with Cassandra database over the 5 years. I'm working as a database administrator, and I've worked upon so many performance issues, migration, and administrative tasks. So this is my agenda. I'm going to talk about. I'll be talking about how tombstones are created, issues, and how we can verify their presence, types of tombstone. And in the last, we'll be seeing some tuning and how we can get rid of existing tombstones. First thing first, how Cassandra delete and how tombstones are created. In Cassandra, everything is a write. Even deletes are also a write. So whenever delete happens, Cassandra write a special value known as tombstone to indicate that data has been deleted. In Cassandra, deletes are not immediately purged. So when you delete the data, it is going to stay there. It is not like it is going to disappear. Data will be staying for certain amount of time. And after that certain amount of time, it will be purged. And that's it. That was all about Tombstone, right? If that's it, then what is so tricky about it? Why I'm giving this presentation to explain about Tombstone and why Tombstone creates so many issues. Because now we know that delete creates the tombstone. But what are the other reasons behind the tombstones? We also insert tombstone into the Cassandra cluster. So these are the other reasons: setting TTLs, inserting data into parts of a collection, inserting null values, and materialized view. So how setting TTLs create the tombstone? When we create key spaces or table, or when we are inserting the data into the table, we can define the TTL, that is time to live. For example, while inserting the data into a table, I have defined my TTL is going to be 20 minutes. So I'm giving Cassandra instruction that, okay, after 20 minutes, mark my data as a tombstone. So this is the way I'm introducing tombstone into the Cassandra. And how we insert, like while inserting data into parts of collection, how it creates the tombstones. So we have to be very careful while dealing with the Cassandra data types in the collection data types, because in the internal structure of Cassandra, whenever we insert and update the collection data types, it wants Cassandra to do read before write. And because of the performance issue, Cassandra doesn't do read before write. So whenever we try to update a collection, Cassandra is going to mark the previous data as a tombstone. So collection always we insert and update a collection, it's going to create the tombstone. Here on left hand side, you can see I have created a key space where my location column has map collection data types. And on right side, you can see I'm trying to enter the single values. Though I have already defined that I'll be entering 2 values, but while entering the single values, it is going to create the tombstone. So be careful while using the collection in the Cassandra. You might be unknowingly inserting tombstone into the Cassandra. Third reason behind inserting a tombstone into the Cassandra is null values. You can see here on the left hand side, I have a table movements, and for the username column, I'm trying to insert null value. So on right hand side, you'll see that for the null values, Cassandra has entered a tombstone. So on the right hand side, by the way, this is the output from the SStable dump. SStable dump tool is provided by the Cassandra, and it helps us to know the internal content of an SStable. We'll discuss more about SStable during this presentation. And the last thing is materialized view. So in the simple words, materialized view is a kind of table on the base table. So it allows you to define other column which are not part of partition key into the base column, but you can define those columns as a part of partition key or the primary key in the materialized view. Materialized view are automatically handled by the Cassandra, and they were introduced, I guess, in Cassandra 3.0. So let's see how materialized view creates the Tombstone. In left hand side, you can see I have a table CC transaction, and if you see in the last, my partition key is user ID and my clustering key is month. And on right hand side, this is my materialized view on the table CC transaction. So if you see the last thing, user ID and year are my partition key. I have defined year as a partition key over here. So think about a scenario where I want to update the year column in CC transaction table. Simple, right? I can go ahead and update the year column. But what that update is going to impact on materialized view, because year is a part of partition key in materialized view. If we update the year column, Cassandra has to rewrite the entire partition for that view, and it has to delete the previous partition. And when it has to delete the previous partition, there will be tombstones because of it. So those were the reasons behind the tombstones and how we create the tombstone into the Cassandra. Now we must be thinking that if tombstones are that bad and tombstone create issue, why we have tombstone in the Cassandra? Actually, tombstones are needed into the Cassandra. That's how distributed delete works in the Cassandra. They are not an issue. They are not an issue until you start seeing a lot of error, warning, and performance issue. And if you have already started seeing those issues, then you might have to do something about it. So let's see what are the issues created by the tombstones. There are, think you have a read query and you are running that read query, and that read query is scanning lot of tombstones. If that read query has to scan lot of tombstone, it means it is going to create the heap pressure, and it is going to create latency. It is going to create read latencies. And if that number of the tombstone goes higher, it will trigger some timeout and exceptions. And if your tombstones are lying on your disk, it means they are consuming your disk space also. See, these are the issues. These are the most frequent issue created by the tombstones. Now, how we can verify the presence of the tombstones? First thing first, we need to check the logs. In the logs, you can see some warnings, error related with the tombstones. So for that, we have two parameters in Cassandra.yaml. First is tombstone warn threshold. The default value is 1000. So whenever a query is scanning more than 1000 tombstone, it is going to log a warn. So if you go into the Cassandra.log, in case you have the tombstone, you can see how many number of the tombstone were scanned. Like maybe it has scanned 1500 tombstones. So that logging is going to say that query has scanned 1500 tombstones. So you can see the warning over there. And in case the query crosses 100,000 tombstone, the query is going to abort. The Cassandra will abort the query, and it is going to log a warning message in your logs. These are the Cassandra.yaml parameter. These numbers can be tweaked, but we doesn't advise that because there are some plus and minus for that. Second, how we can find the presence of the tombstones. We can use SStable to JSON and SStable dump. Earlier to Cassandra 3.0, SStable to JSON was available. Now in the latest version of the Cassandra, we have SStable dump tool available. You can run that tool on the full path of the SStable file. It will help you to show what is the internal content of that SStable. I'll show you how as a stable dump output look like. If you remember, we have seen in the previous slides also. Another thing is as a stable metadata. We can run as a stable metadata on full path of as a stable, and if you are running that on single as a stable, it is going to show you the droppable Tombstone ratio and the delete timestamp. And the delete timestamp will be epoch timestamp. You can convert that and get to know when that data was actually deleted. Third is tracing. In case our query is getting failed and we have no clue about it, what is happening in the background, if in the doubt, then tracing on is a solution. We have to connect to the SQL SH, run the tracing on, and then we can run our query to know what is happening. So here in my example, I'm running a very inefficient query, which is select star from rating by movies. That is my table name, but just for the showing purpose. And you can see in the last, my query is reading 15 live rows and 3 tombstone cells. And if your query is scanning a lot of tombstone, you can get to know, and the number of tombstone is high, then you can blame the tombstone for your query least performance. Last one, not tool table stat. So in earlier Cassandra version, it was not tool CF stat. Now we call it not tool table stat. It gives you a lot of information. But in the matter of Tombstone, if you see in the last, if you see the snippet and the last 2 lines, average Tombstone per slice and maximum Tombstone per slice, you can get to know what has happened in last 5 minutes and how Tombstone per partition keys were accessed in last 5 minutes. So that's how we can verify the presence of the tombstones. Now, let's think, if we don't do anything about the tombstone, then when our tombstones are going to get evicted automatically? They'll be evicted after the GC grace second, which is default 10 days. And if you think, okay, 10 days has passed, now 11th day, my tombstone will be evicted out. No, that is not the case. Once your GC grace second has passed, once that 10 days default period has passed, in the next compaction iteration, where your shadow data and your tombstone data has to participate. If they both are participating in single compaction iteration, then your tombstones are going to remove. And when we say GC grace second, the default value 10 days is just for reason, because before that GC grace elapsed, we need to make sure that tombstone should get distributed evenly across the nodes, and that can be done by the repairs. Now let's see how many types of tombstones we have got. Cell tombstone. We have seen earlier also, whenever we try to insert a null value for a column, or whenever we try to delete a column, it creates a cell tombstone. In my first example, I'm trying to insert null value, and in my second example here, which is delete replacement from item price table, I'm trying to delete a column, and it is going to create cell tombstone. Another type of tombstone is row tombstone. So when I try to delete entire row, creates the row tombstone. Here you can see I'm trying to delete entire row from item price table, and down is the SS table dump output, how row tombstones looks like. You can see there the type is row and deletion info is there. So whenever delete happen, Cassandra mark the time. It has marked the time over there, you can see, and local delete time is also there. So that's how row tombstone look like if we use the SS table jump. Range tombstone. Range tombstones are created, as their name suggests, when a range is deleted. In my query here, delete from item price, if you see price, I have mentioned if price is more than 2, delete the entire range. So it is going to create the range tombstone. Another thing, remember we have discussed how we should be careful with the collection types in Cassandra. If collection type, if you are inserting and updating collection data types, that is going to create range tombstones. This is how SS table dump output of range tombstone look like. Yes, you see the type is range tombstone bound. Partition tombstones, as the name suggests, those tombstones are deleted when we try to delete the entire partition. Assistable dump output is small here because we have deleted the entire partition, but that's how partition tombstone assistable dump output looks like. And the last one, TTL tombstone. Here, if you see in my insert into query, I am trying to insert data, and at the same time, I have defined using TTL 20. So that 20 is in seconds. It means I'm giving Cassandra instruction that delete my data after 20 seconds. So after 20 seconds, that entire row is going to become tombstone, and this is how assistable jump output would look like. You see this TTL defined 20. It has expired at timestamp, and since it is already expired, so it has expired as it has marked that true. Now, the interesting part, how we can get rid of existing tombstone. So first, we need to make sure that tombstones are not getting inserted. We have seen how tombstone get inserted. If we are taking care of that, half of the problem is solved. And then, under most circumstances, the best approach is to wait for the tombstones to compact away normally. But if it is taking a toll on your database performance or causing issues, we can take some steps to evict them more efficiently. So let's see what are those steps and how we can remove the tombstones. First thing, in case you have run incremental repair in the past, or if you have run full repair in the past and not running them now, not running them regularly, then it might be possible that you have mix of repaired and unrepaired assistable that will never be compacted together. So consider a scenario, your tombstone is in repaired at assistable and your shadow data is in unrepaired assistable. So since they'll not be getting compacted with each other, your tombstones are not going to get evicted. So the first solution here is either you run incremental repair regularly, that is not so efficient. Another thing is you should mark your repaired assistable as unrepaired. There's a tool called available repaired assistable repaired set that can help you to mark those repaired assistable as unrepaired. User-defined compaction. User-defined compaction allows us to manually select which file should be compacted. This enables us to reclaim space and limit the size of compaction so it can fit into the remaining space. In the earlier version of the Cassandra, running user-defined compaction was not so easy. You had to use JMX term, then we had to little bit familiar with the Java, and it was a tedious process. But in the latest version of the Cassandra, not-tool utility is there. So you just have to run not-tool, compact, and user-defined compaction, and you have to give the path of SS table. It is damn easy as compared to the prior version of the Cassandra. So, but it is only suitable for size-tied compaction strategy, STCS. And there's a one more blog post I have wrote about it, which is user-defined compaction. If you want to visit, I have shown how it used to done in the earlier version and now how we are doing it, in which cases user-defined compaction can be useful and when you should use them. Third thing, not-tool garbage collect. Not-tool garbage collect command is available from Cassandra 3.10 onwards. This command runs a series of smaller compaction that also check for overlapping as stable. So what not-tool garbage collect actually does, it rewrites all of your SS table with only needed data. It will remove the shadow data from each SS table, but only in the situation if that has passed the GC grace second. If the tombstone has passed GC grace second and they have expired, then only not-tool garbage collect is going to remove data, otherwise it will not. One thing to keep in mind before running not-tool garbage collect is it is very CPU intensive and it is time consuming. Modifying GC grace second. We need to be very careful while modifying GC grace second because prematurely removing tombstone can result in destruction of deleted data. Consider a scenario. I have a table, and the table is complaining about the tombstones, and I want to reduce GC grace seconds for it, but I do not have any idea to what days I should put it. Now, if we are able to run a repair cycle in 4 days, if the repair cycle gets complete without any error on the table in 4 days, then we can reduce the GC grace seconds to 5 days or 6 days from the 10 days, so that Tombstone can be evicted little bit earlier, and at the same time we are repairing the table also efficiently. So that thing we should keep in mind before modifying the GC grace second. And the tombstone will only be removed if the GC grace second have elapsed since the tombstone was created. So that also we have to keep in mind. Last thing, not to compact. I know what you might be thinking. Not to compact is not recommended because it creates a giant SS table that will be very infrequently participating in the tombstone. But that was the case with the earlier version of the Cassandra. Now, Cassandra, in the latest version of the Cassandra, we have an option available: split output, not to compact hyphen split output. In case no other option is working for you, you are in a scenario where running not tool compact is the only solution. You can run not tool compact with this option split output. So it will give you two benefits. First, it is going to compact all the SS table together. So it will be evicting out the tombstone. It will be releasing disk space. Second, won't create the giant SS table. It will be splitting SS table into different sizes of the SS table. Like, for suppose it is creating 4 SS tables, so the sizes of all the 4 SS table will be different. And this option is available in the Cassandra version greater than 2.1. That was all about how to get rid of the tombstone. How we can tune the tombstone compaction. Remember, I discussed how a giant SS table can create the problem. We know giant SS table doesn't take part in the compaction very frequently. So there might be some tombstone lying, there might be some shadow data lying, or it is taking up the disk space. So we need to have some option to run compaction on the giant SS table. So that's when single SS table compaction were introduced. Single SS table compaction were introduced in Cassandra 1.0, and to run single SS table compaction, there are some parameters. The first one is Tombstone threshold. So the default value for Tombstone threshold is 0.2. It means whenever your joint SS table has 20%, it can be with the small SS table also. If your SS table is having 20% of the tombstone, the single SS table is going to get triggered on that SS table. Now consider a scenario. Cassandra has found a SS table having 20% of the tombstone and has run single SS table compaction. But what if tombstone didn't get evicted? Cassandra will run the compaction again. Again, tombstone are staying there. They didn't go anywhere. Again, Cassandra has to run single SS table compaction, because we know SS table needs other SS table also to get compact with each other. So in that case, this compaction stage will enter into an infinite loop. So to deal with that issue, there's another parameter, that is tombstone compaction interval. The default value for tombstone compaction interval is 1 day. So it means the SS table Cassandra has compacted recently, it is not going to enter into the infinite loop. Rather than it will be compacting that SS table after a day. So that interval it will be there. That interval is tweakable. We can tweak that interval to 1 day, to 2 day, or maybe 1 hour. It depends on how frequent we want those compaction and how frequently we want the tombstone to go out. There's one more parameter, which is unchecked tombstone compaction. So before running single SS table compaction, Cassandra has to do some pre-checks, like checking for the overlapping SS table, checking for the droppable tombstone. But in case we set this to true, this can be set in the Cassandra.yaml file. In case if we set it to true, there will be no brick checks happening. So the single as a stable compaction is going to get triggered if the tombstone threshold is like droppable tombstones are more than 20%, and the interval is whatever the interval is set, and the as a stable compaction will be triggering and running. Before setting it to true, we need to keep in mind that since we are making Cassandra to run frequent compaction, this is very resource intensive. This is going to take up a lot of resources. But if it is giving you benefits, then why not? Now, how we can avoid the tombstones issues? First, if we are at the data modeling phase, we need to make sure we are tweaking the data model, we are creating the data model like if, that it should not delete large amount of data. And if that is the need, we have to do it, then we should use truncate and drop, not the delete, because delete creates the tombstone. If you have to delete the entire data into a table, use truncate and drop. And alter your range queries to avoid querying deleted data or operate on a narrower range of data. And all in all, the last one, avoid queries that will run on all partition in the table. That is not even true for Cassandra, not even true for Tombstone cases, but that is true for Cassandra. If you want your Cassandra to run efficiently, if you want your queries to run efficiently without so much latency and problems, we should not run queries on all the partition. We should limit the partition in the queries. Takeaways. And so what we have learned. The first thing is we should run our repairs and tables in the GC Grace second via Reaper. Reaper is a very good tool. If you don't want to use Reaper, then run the sub-range repair. But make sure your data is getting repaired within the GC Grace second. Second thing, setup monitoring. So you can be alerted before before you can be alerted before the big issue arises, and you can fix that beforehand. Third thing, try to tune compaction according to the need. We have discussed the compaction setting available for single as a stable compaction. There are some more settings available. You can tune for the these tombstones. So to deal with the tombstone in a better way. So you should tune them. And the last thing, and the very important thing, is make sure you are not inserting the tombstones. And that was me, and I know it was fast. Sorry for that. Thank you so much for all of your time. I hope I was able to help you a little about Tombstone. Thank you again. Thank you, DataStax.
Let me know once I'm in. Okay. Yeah. Hey, hi everyone. Thanks for the opportunity. Thanks for joining this particular session. So I would like to talk about performance tuning in Cassandra. So more specifically, I'll be talking about secondary indexes in Cassandra. So secondary indexes is one of the most misunderstood concepts of Cassandra, and it is very less known concepts of Cassandra. So what we do today is like we'll try to have a very much in detail technical implementation of secondary indexes in Cassandra. So this talk is like more of a practical approach. I'll have a 3-node Cassandra cluster up and running on my AWS. So we'll be using it, and it will be like more of a practical way of doing things. So yeah, so that is the agenda. So the agenda is like before we jumping into the secondary index, what I do is like I'll try to give you some basics to understand secondary indexes. So that is how we start. Then we'll jump into secondary index and we'll see what are the best use cases of using secondary index, and what are the worst anti patterns. We these are the stuff we're gonna see. And before we start, I know a little bit about me. My full name is Anil Mithana. I'm a certified Cassandra admin and certified Cassandra developer. I really love this subject. Like I'm very passionate about Cassandra database technology, and I also have a YouTube channel running exclusively for Cassandra DBAs. It is purely designed for Cassandra DBAs. So yeah, let's start. So the very first slide, I'll be talking about query first approach in Cassandra. So if you are like in traditional RDBMS systems, right, what we do, we create a table first, then we'll think about our queries, right? There is so much flexibility for how you want to query on a RDBMS system. But in Cassandra, we do in opposite way. So in Cassandra, you need to know your queries first before you're gonna create your tables. So you need to know your application workflow. What are all the queries you do at the application level? You need to have a note of all of these things before you're gonna create a table. So let's say my client came and asked me, hey Anil, can you okay, this is what my requirement. At any given time, I'll give me rows for a particular movie. So, okay, so to make it very simple, I'll be dealing with the movies data so that we can connect easily with the content what I gonna show it later. So this is what my requirement. Hey Anil, can you give me a rows for a particular movie? So this is what I'll ask you at any given time. So if that is what the requirement, what I do is like, I'll gonna create a table like this. So this one. So I'm going to create a table, something looks like that. So where my partition key is my title, and this is what my partition key, right? So email is my clustering column, which gives me uniqueness per my primary key, but the main focus would be the title. So title is my partition key. Now, so this is how you create a table, but let's create a table and let's load some data. So I have it ready handy for us so that we can quickly create a table and load some data. So this is the table I'm going to create, and I'm inserting some rows. Then we're going to query that table also. So yeah, so I have a 3-node cluster up and running. So that is looking perfect. So I'm connecting to my SQL SH client. From there, I'll switch to my key space. So you have to use command is the command if you want to jump into that particular key space. So that is where I'm going to create a table now. So I'm creating a table, and I loaded some data, and here we have a data. Now, before going further, what I do, like I'm using a tool called Mobile Strum. I think previously one of our speaker already mentioned it about Mobile Strum. This is a wonderful tool, especially on Windows if you want to manage your Cassandra clusters. This is a very good tool to connect and use it. Now, so I have a table, and so what is my requirement? So my client asked me, hey Anil, can you give me all the rows for a Avatar movie? So I want to know who and all watched and what and all ratings given to Avatar movie. So what I do is I'll run a query something like this, right? So let's start from table where title is equal to Avatar. I got the output, right? And what is more special about it? Like, is there any special thing about getting this output? Yeah, yes. Now, what is that? See, to give you that output, because Cassandra is a distributed database, what happens, in Cassandra, your table basically will get distributed by using your partition key. So this is very important. If you notice here, your table will get distributed, but in terms of partitions. So if you ask me, hey Anil, can you tell me what do you mean by Cassandra table in Cassandra table? I'll tell you, Cassandra table is a collection of partitions. So that partitions will contain rows belongs to a single partition. Now see, uh, whoever is watching Avatar movie, that data will be in one single partition, and that partition will be in a single node, one single node. So let's say you have a three nodes here, right? You are seeing three nodes. Maybe how Cassandra will store is, it keeps the Avatar data in one single node, probably on node one. It stores the Interstellar movie probably on node two. No, it stores the Lucy movie data in node three. So you got this, how it is storing. It is storing so beautifully, right? Now, what is the advantage, by storing in that way? See, when you query, just now I ran a select query. Now, to give you this output, it's a single discrete output. That is the power of Cassandra. So when you run this query, it just goes and grab it from one single node. It's a single disk, single disk read. So you get it so quickly. So yeah, now that is one way of having advantage. But there are some because you are getting an advantage from one side. There is a flexibility issue, with your select queries, and especially with the partition key. See what I mean by that? Now, see, if client came today and if he asked me, hey Anil, can you give me rows, for a particular user? Like I want to know all the movies watched by a particular user. See, if that is what your query, I'm sorry, I cannot give you that output, because you remember it's a query first approach. You need to know your queries much earlier before you create a table. So we already discussed our application workflow or queries, and today if you came and asked me some different query, Cassandra cannot give you that. So that is where duplication comes into the picture, denormalization comes into the picture. So especially if you are from RDBMS world, right, and if you are coming into the Cassandra, it looks similar, a little different, right? It is because it is completely opposite. In Cassandra, duplication is completely allowed. Cassandra encourages you to do duplication and denormalization, right? Now, if you want to look up by email, you have to create one more table with the same data. You need to duplicate it. So that is the best way of fetching the data for you if you want to look up by email, right? Now, so I have already created this table, and I'll show you how it works. Now, if you notice, what I just did is I created a ratings by email, where email is my partition key. And I loaded same insert queries. I mean, there is nothing changed. Everything is same insert queries, right? Now, when you store it, if you see how it is storing, now it is storing by keeping your user as a partition, right? Everything watched by Sharma, everything watched by Ram, it's keeping in a one single partition, and that will go and sit in one single place. So anytime if I want to fetch the rows watched by Sharma, I can get it so easily. It's a single discrete. anything, you know, from any movies, like, you know, watched by Pile, I'll get it so easily, so quickly. Yeah. Now, all good. So duplication is there and denormalization is there, like all good. Now what is next? Now let's say, you know, there is one more requirement today. All of a sudden client came and, you know, asking me, hey Anil, can you give me rows where rating is equal to 8? So I want to know all the movie list where rating is equal to 8. So can I get that? Can you give me that output? You know, a big sorry, right? I cannot give you. You cannot change your queries, you know, day by day. So if today if you come and ask me, give me rows where rating is equal to 8, you know, I cannot give you that. See, it is giving you an error, right? Cannot execute this query because there could be unpredictable performance issues. But if you still want to execute this query, Cassandra is telling me to use hello filtering, right? Let's say, you know, some developer, a new developer from read this message and he ignored everything and he just focused on this particular piece, hello filtering. Let's do that. So what he did is he ran this query where, okay, we need to, this is the query where rating is equal to 8. It is throwing an error and Cassandra is telling me to do use allow filtering. So it is not here use, it is allow filtering. I got the output. Now the developer is so happy. See, it was like previously throwing an error and I used allow filtering. I'm getting the results, right? Now, this is where the main drama comes into the picture. Allow filtering is completely bad. Now you are not supposed, I mean, it is not advisable and there should be a big no if on allow filtering. Now what just happened? Why you shouldn't use allow filtering? Let's say you have 2 lakh records in your table, okay? And there were like 100 records where rating is equal to 8 out of 2 lakhs. So what just happened is, when you ran this query, what Cassandra does is it will scan all the 2 lakh records and then it will apply the filters on it and it will give you the output for you. So basically, you know, you are doing a full cluster scan, right? Which is completely bad. It may bring down your node if you use allow filtering, right? So completely bad. You know, that is the recommendation, especially if you are on a production. Try not to use allow filtering. Now, what is the fix, right? There comes your index. Okay, this is where we are jumping into the actual topic, secondary indexes. Now, what I do is I'll create an index on rating column. So I'll clear my screen. What I'm doing is I'm creating a secondary index on my rating column. Now, previously error, right, for this particular query. So we ran allow filtering. So now what I'm doing, because I have a secondary index now, I'll run that query and I got the output. So if you have a secondary index, I know you can get the output. Now, here comes one more point. So then if it is working fine, if secondary index is giving output properly, then why you told me to duplicate the data? Now, when I want to look up by email, why can't you go and create a secondary index? Why you told me to duplicate it and now you're telling, you know, create an index and get the output, right? So this is where, you know, we gonna complicate our things. So, you know, little bit more focus is needed. Now what I do is like to demonstrate. Now I have two options, right? If I want to get, if I want to look up by ratings, I have two options. One option is duplicate the table with the same data, or else create a secondary index and use secondary index to get the output, right? Two things. Now we have one thing already there. What I do is like I'll create a duplicate table by, see, by keeping rating as a partition key. Now what I'm doing, I'm creating same data, loading same data, but I'm just changing my, I'm duplicating it by keeping rating as my partition key. Now, so select start from ratings by ratings where rating is equal to, now, so I got the output. So here in this screen, you are seeing you got the output by using secondary index. in this screen, you are seeing the output from a duplicate table, right? Now, if you can able to understand the difference between these two, how they are getting stored, I mean, how secondary index is storing and how a duplicate table is storing the data, you get a better idea about how to implement secondary indexes in Cassandra. Now, when I query from my duplicate table, right, from the original table, right, from here, it's a single disk RAID. We just we understood this already, right? Because rating is my partition key. Remember, partition key is what a primary index. Like all the time I'm talking about secondary index. Like you might be getting a doubt, like what I mean. Then what is a primary index, right? So primary index and partition key both are same. So primary index is what here you are looking here. Now your primary index data basically will get distributed. What I mean, right? See here, every time someone gives a rating 8, that will come and sit in this particular partition, right? And this partition will be in a single node, right? So probably this whole data might sit in node 1. All the people who were giving rating 7, that will be one single partition and that will be stored in a one single node. Remember, your partition data will never get distributed between the two nodes. So one single partition will belongs to one single node. Now, when I ran this query, it's a single disk RAID, correct? It only one single node involved in this particular output. So to give you this output depends on your replication factor. Let's say you have a replication factor set to 1. Now in that case, it's like it's a single. This query uh, involved only one single node. Now, what about secondary index then? How many nodes are getting involved when you run using secondary index? That is the whole concept of secondary indexes. Now, to understand, you need to understand how secondary index will be stored inside Cassandra when you create them. Now, so when you create a secondary index, we already know how to create an index. Now, when you create an index on, let's say in our case, we created it on a rating column. Now, what happens is Cassandra will create a hidden table for you and it will manage everything, in the background. You don't need to worry about it. Now, so Cassandra creates a hidden table, and if you notice, your primary key rating is your partition key, and meaning in the secondary index, rating is your partition key, and it will take entire primary key as a part of the rest of the primary key in the hidden table. So this is how the table looks like. Now, how table data, index data will get stored, right? So this is the original table and this is the index table, right? Now I'll show you our how it gets stored. So this is very interesting. We'll pay attention a little bit more here. Now, this is your original table, right? Where you are storing data by title. And on this table, you created a rating, right? Now, when you create a rating, you have a one more table got created. Now, here comes your index data. So the main difference between your base data, this is the base data, right? Original table data and the index data. What is the main difference? The main difference is your base data will get distributed, meaning all avatar data will be in one place, all industrial data will be in one place, right? But if you notice your index data basically co-locate on the same node with the source data. So confused? You didn't get it what I just said. So let's pay attention here. Now, what happens is your index data will be co-located on the same node with the source data, meaning your index data only local. So here, like three people watched, three people given rating 8, three people will given 9, and three people given 7, right? Only that data will be stored on that node, right? Now, what is the disadvantage by storing in that way? Let's run this query. Select star from ratings movie where rating is equal to 8, right? This is what you're querying using secondary index, right? Where rating is equal to 8. Now, your Cassandra cluster doesn't know where is this rating 8 data. See, if you say where rating is equal to, if you say where title is equal to avatar, see, everyone knows about it now. So every node knows where avatar data is because that's the primary index. But if secondary index data, no one knows, like your Cassandra doesn't know where is the data. Basically what happens now, it has to hit every single node to get the data, right? See, everywhere people given rating 8 for every movie, and it has to go and scan every single index data, and from there it has to grab the primary index. I mean, uh, uh, it has to scan index data. From there, it has to grab the your primary key of base data, and it has to go here and get the output for you. So every time you read, it has to look up your index data, it has to look up your base data, and it will happen in every single node. Let's say you have 100 nodes, all 100 nodes will get involved when you look up by secondary index. Okay, let's say you have a replication factor, let's say 3, and you have 100 nodes. Even in that case also, you have to hit at least 33 nodes. I mean, which is really bad, right? Even though it is 33 nodes, still it is huge. Now, so you might ask me, hey, why, in that case, why it is storing that way? Why cannot it just stores the way it is storing the primary index? Like, why cannot it? Why it is not storing index data also like this? Keep all the 8 data in one node, keep all the 7 data in node, keep all the 9 data in node. Why it is not doing that? So there are two issues, if you store that way. Let's say, imagine your secondary index is storing this way, right? It is keeping all the rows where rating is equal to 8 in one single place. Let's say you have like 5 lakh records. Out of 5 lakh records, let's say 90% of the rows having rating is equal to 8. So most of the people given rating 8 for movies. Now what happens if you store the data of 8 in one single node? You will end up with a wide partition, right? You will end up, that particular node will have a wide partitions, right? Additional load on that particular node, which is bad. Again, one more thing. Uh, by keeping index data local, it is easy for you to update indexes. So there won't be any index latency issues when you are doing mutations, update, deletes, inserts, whatever you're doing on your base data. It has to get updated in index, right? So when you have it local, it is so easy for you to get updated. But if you distributed it, there can be consistency issues, right? That is what you're getting from materialized views, isn't it? So basically, materialized views is like distributed index. So that is where you see all the latency issues. So to avoid all of them, so Cassandra having these two reasons to store index data along with the original data. So we already discussed these 2 points. Now, by this time, I hope you already got to know what is distributed index and local index, right? Local index is what your secondary index, where every time if there are 100 nodes, all 100 nodes will get involved, right? Distributed index are like much better way of querying the data, because let's say you have 100 nodes with 5 replication factors set to 5. Maybe when you query 5 nodes and one coordinator node, hardly like 6 nodes will be involved in your query. Now we also see what is the write path and read path. Now I hope we already discussed what is the read path, right? So every time you look up by index, it has to scan index data and your base data, and get the data, right? What happens with the writes? So whenever you are writing, whenever you're doing a mutation, right? Mutation meaning like inserts, update, deletes on the base data. So there is a hook. There is some kind of notification will be sent to all the registered indices on that particular table, and your base table data and your index mem table both will get flushed into the SS table, into your disk, and there is no guarantee both will get flushed at the same time. And once it got flushed, your index data and base data will have a different life cycle in terms of compactions and repairs. So that is also you have to consider. They don't have a same life cycle. So your index data will be compacted differently, and your base data will get compacted on a different way. Now, so all the time we were like almost like it's a complaint. We were like trying to understand what is the complexity of using secondary indexes, right? Now, if this is so much complicated, why we have secondary indexes in Cassandra? There should be some reason to have them in Cassandra, right? Yeah, there are reasons actually. There are some best use cases to use secondary indexes. Now, I'll put a one statement. So secondary indexes in Cassandra will not give you performance. They are there to give you convenience for your queries. So very important statement. They are not there to give you performance. Okay, they are there to give you convenience for your queries. What I mean by that now, uh, let's look into our. So this is what expensive query, right? When I run where rating is equal to 8 on my secondary index, it get all the nodes will get involved in that particular query. Now, what would be the right way of asking when you have a secondary index? Now, I'll tell you this. Now, so instead of asking select star from ratings by movie by movie where so rating is equal to 8. I mean, this is bad. This is expensive query, right? Now, what was the right way? Now, ask include your primary index also. Title is equal to avatar. So this would be a proper way of using secondary index. Now don't ask me, give me all the rows for where rating is equal to 8. I mean bad query, expensive query. Ask me this. Give me all the rows where rating is equal to 8 for a particular movie. So I want to know who and all given rating 8 for Avatar movie. So that would be a right query to ask Cassandra. So when you ask that, what happens? It's a single disk read. Where the moment you include your primary index, it becomes a single, right? So it doesn't need to hit any other nodes, right? It has to go and hit only one single node. So this is a more real-time transactional query, than this. This is more expensive, and this is the less. I mean, actual query to use actual implementation of secondary indexes. Now, let's say there is one more way you can use secondary indexes. Now, instead of asking all the rows, let's limit it. Let's say limit to. I'm doing, I'm asking, hey, I'm limiting my rows, number of rows. So to two. Let's say you have a, you want to limit 100 rows. Okay, like let's say you have 100 nodes and you are fetching only by 50 rows by saying limit 50. Now, what happens? Cassandra will have an internal mechanism, internal algorithm. So what it does is the moment it gets the those 50 rows, it will stop scanning other nodes. So that's how you can actually, let's say you got 50 rows by scanning 5 nodes. So it will skip remaining 95 nodes and it will give you the output for you. So that happens internally. Now the basic idea is, try to narrow down the number of nodes you query. See, by keeping primary index, you reduce the query to one single node. By keeping limits on your query, so by keeping limits on your query, you're also narrow downing your number of nodes to hit, correct? So these are some actual implementations of secondary indexes in Cassandra. So they are there to give you convenience, right? This is what the convenience they will give you for your queries. They are not give you performance, right? They are also good for analytics workloads, especially on if you're using Spark. Secondary indexes are very much helpful because there won't be SLA that measured in milliseconds on Spark side. Now this is very important, especially if you are from traditional traditional RDBMS world. You have to know what are the worst anti patterns, because I see most of the developers coming from RDBMS, they tend to create indexes, right? See, that is what happens in traditional RDBMS systems. Whenever there is a query performance issue, a DB or a developer tend to create a secondary index. I mean, it's a very common practice, creating an index. In most of the cases, it will resolve the issue, right? But in Cassandra, we already got to know it is not the right practice to create indexes whenever you want to create on whatever the columns you want to create, right? Obviously, we have to avoid creating index on very low cardinality column. Let's say gender. So gender is having only two columns. I mean, two values, right? Okay. So gender is having very low values like 3. So you will end up with wide partitions if you use gender. I mean, if you create a secondary index on a gender column, so which is very bad. And you should avoid creating indexes on very high cardinality columns also. For example, email. So email is like very much unique value. Every row will have a unique value, and it is completely bad because if you create a secondary index on an email and you are looking for that particular email, you might end up getting the output by hitting one single node, or you might end up hitting every single node and getting a result 0. So completely you should avoid it. Now you have to avoid creating index on a column where you will update very frequently, right? You shouldn't create it on a column where you update a column values repeatedly, right? So these are some worst anti-patterns which you have to avoid. Now there are problems and limitations. We already got to know some kind of problems, and the limitations, right? You are not allowed to use range queries on secondary index columns. I mean, you can say rating is equal to 8, but you cannot say rating where rating greater than 8 or rating less than 8. They are not possible on secondary indexes. And also, because this whenever they get index data and base data will get flushed into SS tables, they follow a different life cycle and different compaction process. And you there also you will end up having some issues if the base data are compacted quickly and your index data is not yet compacted. There is a mismatch again. So there are some limitations when you use secondary indexes, and that is where we talk about SASI storage. SS table attached storage index. So here, when SASI index also one type of a secondary index where it gives you more flexibility when you query. Basically, it allows you to use range queries. You can use like parameters on your on your index column. So very much similar. What we do is like we'll try to create a SASI index also quickly. So what I'm doing, I'm creating a SASI index on user location column. So here on this user location column. So and you have to pay attention to this warning. SASI indexes are experimental. I mean, they are not recommended for production use. We'll try to understand why such warning was displayed. Now once you have a SASI index, you can use like parameters. So let me run this query. So I can get the output where user location is like anything like starting with you, right? And again, it's an expensive query. Everything is all the entire implementation is same, and it is expensive query. It hits every single node as we discussed, right? Now what is the much better way of querying? Always include your primary index also in your select query, right? So give me all the rows where user location is like percentage, and where title is equal to avatar. So that would be a much better query, and it will hit only one single node. All good. Now, so that is what SASI will do. And one more thing, SASI will have uh, SASI will have a physical representation. What I mean by that is like the moment you flush. So let's flush it. So your index will have SS table along with your base SS table. So what I mean by that, like let me clear my screen and let's jump into the base, and our table name is ratings by movie. So here where we created SASI, right? And if you notice, your index data also will have your SS table, right? And these SS tables will get involved in your compactions and in your repairs. So you have to be very much careful. Obviously, you're putting additional pressure on your compactions and on your repairs if you have a SASI index. So that is where you need to pay attention when you are creating a SASI. You obviously you're putting additional pressure on your compactions and repairs. So anyway, as of now, SASI indexes are experimental, so make sure you're not using them on production. If you're using them, contact the support. Now, so that's almost, we are ending into the final topic. So I would like to put some final thoughts. Obviously, secondary indexes are there to give you convenience. I mean, this is, I'm stretching from the beginning. They are not there to give you performance. Okay, do not try to create all the time secondary index, on whatever the columns you wanted to create. This is bad, right? You need to understand, how Cassandra is storing the data, secondary index data. What would be the right way of querying if you have a secondary index? Always try to put primary index in it. All otherwise, try to limit the number of nodes you are hitting, right? And the much better way, the very generic recommendation is to have one secondary index per table, or else almost try to avoid creating them. If it is like if the requirement is like much suitable to have a one more duplicate table, always go ahead and create a duplicate table, because uh, querying on a primary index like on partition key is much faster than querying on a secondary index. So that's it. So yeah, stay home and stay safe. Thank you for the opportunity. Thank you for the opportunity. I'm very glad to be speaking on this particular platform. Yeah, thank you so much.
Are we on? Yes. Hello, everybody. So you can hear me well? Okay. Good morning to people from US side and good evening for people in India. I'm very happy to be here on the Cassandra Day India. And I'm very happy to talk to you about Grafana dashboard for Cassandra. Okay, so let's get started. So when you have big clusters or small clusters, it doesn't matter what kind of clusters you have, what size it is. We definitely want to see how your clusters are performing, like the metrics, and we want to definitely make sure that they're all healthy, and you should be able to quickly identify if there are issues in your clusters. So when I started looking for Grafana dashboard for Cassandra, so what happened was I will show you live. We'll go to the Grafana website and find some dashboards. The issues I found was all the existing ones were old, at least 2 to 3 years old, and they were all broken because of Grafana itself released new versions. So basically, when you have new versions of Grafana, you have to go back and make sure the dashboard works. And a lot of people who developed it earlier, I know they must have not keeping it up to date. So old ones were old and broken. And the second issue is all of them, there are at least 10 Grafana dashboards. All of them use something called JMX and jar. So everybody who uses Cassandra definitely knows about JMX. We all were told that that's how all the metrics are published, and that is completely not correct, meaning there are other ways to get the metrics out. And then, somebody builds this Java code, they write Java code and they build a compiled jar and they tell you to plug it into your production cluster. I personally, I would not plug any unknown jar into my production cluster because I have no clue what that jar does. Does it only collect metrics or does it collect metrics and sends it to unknown targets? So I have no clue. Now that was my issue. So if you just want to quickly see where these dashboards are, basically I will just go to Cassandra. So let me just go here to grafana.com and you see these are the dashboards. So if you click on this, so anybody who is looking for dashboards, they'll get here. And then I'm going to just type Cassandra just to see the filter. And you can see all of these Grafana dashboards. There are mostly 9 to 10 of them. And these are the dashboards I was referring to. Let's say randomly, let me pick one of them. Let's say, for example, this one. So this one was built 5 years ago. And it was built for Grafana 3.1 version. So this is very old. Now that's what I meant when they all created this Grafana dashboards. These are old and they're not up to date. So that was my first issue, as I was explaining. And the second issue is the JMX. So how do we solve this issue, right? So basically, I started learning Prometheus Grafana. There is a lot of learning to create a new dashboard. But if you're going to use this dashboard, then you don't have to do all this learning. Now, what I did was from my side, I was thinking about a couple of options, right? One is I don't want, like I told you, JMX is complicated. I don't understand JMX. I'm not a Java programmer. At the same time, I don't want to plug unknown jar, which I explained earlier, right? Somebody wrote some Java code, which I don't want to really plug into my production cluster, right? Even if it is test cluster, I don't want to experiment with somebody else's Java file or Java code. So um, what if we don't want to use JMX and we still want to see these metrics, right? I started experimenting with Cassandra itself, and Cassandra has a wonderful tool called Metrics Reporter. In a second, I'll show you what that is. And then I would like to use the latest version of Prometheus Grafana and make sure the dashboards are kept up to date. And then keep it simple is my concept always. Like, if at all you can do something with simple stuff, you can do it. And that also refers to the JMX part of it. I don't understand JMX, so I keep it simple with shell scripts, right? So let's talk about how we can get these metrics out from Cassandra, and let's see if Cassandra already offers some pre-canned way of getting these metrics out. Okay. One thing I want to mention, and earlier two speakers talked about this, I use MobiXterm for all my SSH connections on Windows, connecting to my servers. What we'll do is we'll just do a quick rundown. I'm running a Cassandra 4.0. So let me quickly check the version. And you will see that I'm running Cassandra 4.0 beta 4. And let me show you my Cassandra cluster. So I have a 6-node cluster. Let me just push this up a little bit. Okay, I have a 6-node cluster, and there are 2 data centers, 3 nodes in each data center. Pretty basic setup, but you can see all the nodes are up and running and all. Now, most importantly, we want to talk about the metrics collector. We don't want to use JMX, so what is the alternate for that, right? So if you look at Cassandra documentation, there is a metrics related information published in the documentation. So I'll just go to cassandra.apache.org and go into documentation. I'm going to look for something called metrics. And let's see, under monitoring, you see this metrics come up, right? Now, what Cassandra was built for is, by default, Cassandra is built to publish metrics using something called drop wizard metrics library. And also the same metrics are published via JMX. So there are 2 ways Cassandra already comes out of the box. There are 2 ways to get these metrics out. JMX is by default enabled on all the nodes. What we are looking for is the alternate method, and which is already available via Cassandra is, it's a very simple setting. I'll show you how it is configured. So first of all, we go to the configuration folder, and there is a file called metricsreporter.yaml. Okay. Along with the original configuration files, there is a sample file available for this. And what you see here is I have provided, okay, so one more thing to mention, all this information is already available on GitHub, and we are just reading off through the GitHub, but I'm going to show you how this entire setup is done. So what it tells you, basically, this particular configuration file is telling Cassandra to write all the output, the metrics, to a specific file, and it tells at what intervals we want to write these metrics into the text file. And then there are a couple of other settings here, but most importantly, if you notice here, you can exactly see what metrics will be dumped into the text file. Okay. Now, if you went with the JMX configuration and that jar file, I'm telling you, somebody wrote this jar file. I don't know what jar file collects, right? But if you are using this text file or the YAML file configuration, you can exactly tell what metrics to capture, and you can direct it to the specific file. Now, what I have done here is I wrote this YAML file, basically is telling Cassandra every 15 minutes, take all the metrics and dump them into this text file, right? I can quickly show you. Let me quickly say, for example, show you how the text file looks like. Let me do one thing. Tail minus 100 lines from this text file. This is much better. So what we are doing here is we are looking at the text file which is generated by Cassandra. It is writing all its metrics into this text file. And later we are going to see how we take this and pump it to Prometheus and Grafana. Hold on one second. Looks like my screen froze for some reason. Hold on one second. Okay, I might have to stop sharing and start the sharing again. Give me 1 second. Okay, now this is better. So you should be able to see my screen. Okay, so this is my guess, right? When I switched to Mobile Extreme, I think that's when you did not see the screen share, I guess. Okay, so what we'll do, we'll go back one step. I'm in the configuration folder for Cassandra. Ignore my versions and all that. What you see here is, let me hide this. Okay. In the configuration files, there is a configuration file called metricsreporter.yaml. Okay. In the original configuration files also, you get a sample file which looks like this. So this is what I was explaining earlier, but you did not see it on screen. It's a very simple YAML file. Basically, it explains Cassandra should write output to this text file and take all the metrics. Every 15 minutes, it is going to write the metrics, and the metric configuration looks simple like this. So basically, we are telling what kind of metrics we want to dump into this text file. Okay. Now, all this is in the documentation. So basically, you can go to the documentation and you'll clearly see what metrics can be dumped. And all these metrics are documented very well. So once we have the metrics configuration done, we have to still tell Cassandra on how to, I mean, when Cassandra is starting, it has to know that it has to dump these metrics. There is a Cassandra configuration file called Cassandra n.sh. So that file is Cassandra n.sh, this file. So if you look at the tail of this file, I have added one entry in this file, and you can see here this file contains a lot of JVM options. In this options, I'm just adding one extra parameter here, which tells that I would like to use the metrics reporter, and the configuration file is this YAML file we created. And the YAML file we created should be put in the configuration folder where Cassandra has all the other configuration files. When you start Cassandra with this setting, Cassandra starts writing logs into the text file earlier I was showing you. So I can show you the text file one more time. This is how all the metrics will look like. When you look at this text file, it contains all the metrics dumped into a text file, right? So our goal was to avoid going through JMX and avoid going through plugging a jar which is unknown. What I did here was a very basic. Cassandra already has this pre-built metrics writer, which I'm telling, okay, take all the metrics every 15 minutes, write them into this particular text file. Okay, that was the step one to get the metrics out of Cassandra, right? Let's go back to the slide. And so what I was telling is, don't use JMX. That is the first solution. use latest Prometheus Grafana, we'll get to it. Keep it simple, right? So the step one was to get the metrics out. We performed that step. Now, just to show you how the architecture of this particular solution looks like, if you look at this, I'm just showing you 3-node Cassandra cluster here. There is a shell script which we are going to use to get all the metrics prepared for Prometheus format. Each Cassandra node will run an agent called node exporter, which comes with Prometheus basically. And then that node exporter publishes all the Cassandra metrics as a website or a web page. Prometheus goes and brings those metrics from each server. We'll configure Prometheus to look at each server node exporter output. And Prometheus also has a component called Alert Manager. We can configure Alert Manager in case if we want to send alerts, like a page to the DBA team or the application team, if at all something goes wrong in your cluster. And Prometheus is a time series database. It keeps all the data in its own format, but we can take those Prometheus data, the metrics which we collected from Cassandra, and display them as Grafana dashboards. So this is a basic architecture of how the Grafana dashboard is built for Cassandra. Now, let's take a look at how the dashboard looks like before we jump into more details about how Prometheus is configured and all. Okay. So let me switch to this screen here. So this is how the Grafana dashboard looks like at the end of configuration. Like once we have everything configured properly, this is how it looks like. What I did was added few filters here. Basically, you can filter by the cluster name. Let me zoom into this top first. And then once we explain, we'll go back to looking at the cluster. So you see, this is the cluster we are monitoring right now. I have only one cluster, but if you had multiple clusters, you can look at the cluster configurations from one place. So right now we have only one cluster. And you can also do further filtering using data centers. I have 2 data centers. So it is listing both data centers here. I can select one or the other or both of them. At the same time, this will also show you which hosts or the server names available. So you can filter based on the server names. Further, you can filter based on key space and table names. We'll go there later on. So what I'll do is I'll just reset this size and show you the system summary. So the entire dashboard is divided into multiple sections here. I'll go with the system summary first. You can see here. So basically this gives you a quick summary of what kind of operating system we are running. We have 6 servers in this cluster. It tells you what is the uptime, what is the operating system. As you can see here, I'm running CentOS Linux 8.4, pretty latest version of operating system. RAM usage is a little bit high. You can see it's like almost 70%, 70+% on the RAM. There is only one server having CPU issue. So you can see CPU is at 76% on one server. And the color coding basically keeps it very simple and easy to understand. Okay, that there is one server which is standing out there in red color. You might have to check what's going on with the CPU over there. We can expand the next section, which shows the storage. There are 2 things here. Like if you had multiple mount points, it will show you all the mount points and their usage. And the simple LCD gauge will show you, like, if it is reaching red color, then obviously you have to make sure to add more space or expand space. We can also monitor the inodes. Generally, when you have multiple files and too many files, your inodes quickly fill up if you don't have enough inodes. That's one of the common issues with Linux. And we just have to make sure we monitor those inodes and take care of them if at all they're consumed. So there is next one shows the first three sections show the system related information. So here you can see the CPU usage over a period of time. Here I'm looking at last 3 hours, and you can look at the RAM usage of the different systems. Now, as I mentioned earlier, right, you can also filter. Let's say, for example, you can pick which servers you want to see, and then you can look at the metrics only for the three servers I picked from the list. Now we keep going. We can look at the summary of the Cassandra nodes. Look, like it tells me that there are total 6 nodes. Let me zoom a little bit. So there are total 6 nodes, and all 6 nodes are up and running. If at all one node was down, it will show in red color. Right now, there are no nodes down, so which is good. I have total 2 data centers, and each data center has 3 nodes. That's a quick summary of the cluster we are looking at. And then we can go further into Cassandra summary, where it shows you what version of Cassandra we are running on each node, which data center we're looking at, what is the rack information for that node, how many tokens each node is handling, uptime, and how much data is on each node. There are two important stats here, like say if you're running repairs regularly, your repair should be at 100%, usually near to 100% or above 90%. If at all your repair rate is like less than 30%, I would be concerned about it. You should not be running any clusters without repairing them. So just we have to take care of those repairs. And the storage errors. Now, I have not seen this metric ever populate, which is good. If at all we had storage errors, it will show up here. And again, as I said, all these metrics are collected from Cassandra using that metrics reporter, and they're published here to, I mean, it's coming from Prometheus, but what we are looking at is Grafana right now. So once I go through this list of Grafana pages, I will go back and show you how my Prometheus looks like, how Prometheus gets the data from nodes. So next thing is Cassandra memory. We all know that Cassandra runs in JVM, and JVM is heap and off heap memories. So you can see here pretty much if you look at one graph, it pretty much starts with basic and then goes up as the time goes on. That is, the heap gets filled up, and then garbage collector comes in, cleans it out, and then heap drops back to normal and then starts growing again. So there is a very specific pattern here. And also this will give you an indication of how frequently your garbage collection is running. And you can see heap allocated, that is our JVM heap, which is 2 gigs allocated. And right now usage, you can see different servers have different usage. And as the usage goes up, that percentage will show up in a different color. And we all know that Cassandra also stores data off heap. And here we are showing how much is the off heap consumed. So this is about the Cassandra memory and the JVM memory used by Cassandra basically. So the next thing is cache. So we know that Cassandra has 3 types of caches, like the key cache, row cache, and counter cache. And remember that the row cache is by default not configured, so it is not enabled. But whereas key cache, you can see right now I have 90% hit rate, which is pretty good, near 9 to 11% misses. But still, if you look at the hits, it is pretty good. So that's how the cache metrics look like. Let's look at the queries. How is the SQL queries running? You can see how many are cached, how many are executed. And we definitely want our Cassandra to perform really well. When our application uses, most of the queries should be prepared queries. You can have now and then your developers will run ad hoc queries, and you will have unprepared queries. Now, if we did not have this kind of visualization, it is very difficult to gather this metrics using basic node tool commands. So it is always better to have a Grafana dashboard, and we tried to put a lot of information and easy to read here. So any of these panels, if they turn red, let's say for example prepared percentage, prepared SQL statements percentage becomes red color, that means you have to look at what is your application is doing. If at all they're not using prepared statements, you have to help them come up with the queries and tune them if required. So after query SQL queries, let's look at the commit logs. So having some pending tasks on commit logs is not bad, but you should not constantly see pending tasks in the commit logs. And other information like how much size is occupied on each server for commit log, that gives you indication of how large your commit logs are on the disk. Going further, we looked at the commit logs. Now I'm looking at the clients, and you can see, for example, how many logins happened, how many failures. Generally, we don't want hints stored. If at all hints are stored, that means there is some server down, and hints are being stored on the other servers where it has to do the hinted handoffs. And if at all any hints are being transferred right now, then you will see the sending count. So this particular information here tells you like how many clients are logging in, how many times if there are any failures. If at all one client has a wrong password to log in, then obviously that will show up in the failures. And having too many failures is not good. You might have to check with how application is configured. Let's look at few other things here. More, this might be more important for tuning your application. One is it shows the latency. And this is where I was talking about, like, if at all you have to filter, you can actually use this filters up there. And you can say, for example, I want to filter for sales key space, and I want to pick only, like, say, for example, couple of tables, right? So you can actually do that filter and it gets applied to rest of the dashboards here. So this one, this metric here shows that there are table latencies, and the latency type, if you notice, right now it is saying node write latency, and there are coordinator read latencies, coordinator write latencies. There are a couple of different latencies here, and we want to make sure why those things are happening, if at all they're happening regularly. This will help you to reduce the latencies, or get insight of which tables are having latencies. Let's go to the key space size. So this particular metric is collected at the key space level. We can figure out what are the key space sizes. Here we are looking at only one key space, and it tells you how much data is stored on each node. It is shown displayed both in a tabular format as well as the graphical format. And you can see on one of the nodes there is a lot of data compared to other one. But difference is not too much. If you look at that's the megabytes difference. So if at all data is properly balanced, then you should not see big difference. Now this is the last panel here, which is the table size. So we are not showing any of the system tables, but you can see here each table and how much size it is at the each node level. And so that's how the dashboard looks like. Now let's go ahead and see. One thing I want to show you is where is this whole project published, right? So you can see this is the GitHub where we published all the information on how to configure this this particular Grafana dashboard, and it also teaches us how to configure Prometheus. Let's say, for example, it walks you through step by step on how to get Prometheus, how to install it, how to configure it. It shows all the configuration required for Prometheus side of it. Now what I can do is I can quickly show you how my Prometheus looks like. So if you, I'll wait for a second here to, okay. So here is the Prometheus, my Prometheus looks like. And basically you can look at the metrics published by one of the nodes. Let's say, if you look at the earlier slide on the architecture, so let's review this architecture for one more time. So you see we have 3 Cassandra nodes, and each Cassandra node has a node exporter, and node exporter is an agent which collects this metrics and publishes it to Prometheus. I have not talked about the shell script yet, but that node exporter, whatever it is publishing, Prometheus gets those metrics and stores them locally. So what I was trying to show you here on this this piece here, let me go back to the metrics here. So these are the metrics published by our node exporter, and Prometheus is able to see these metrics. It'll collect all these metrics and store it in its own time series database. So if you look at one of these metrics, like let me scroll down a little bit. Say, for example, we are looking at a mount point information. Okay. So you see, for example, it tells you what is the mount point, and this is the cluster, and this is the data center where it came from. This is the node it came from, and what is the mount point? Here it is showing the root mount point, and how much is the size of that mount point, total allocated size in kilobytes. Similarly, there are a lot of metrics which are like, specific to Cassandra, like you're looking at the table size um, displayed in bytes. Now, if you read a little bit, right, understanding these metrics is not very difficult because they're all written in plain text. You can look through and understand how Node Exporter is publishing these metrics and how Prometheus is able to consume them, right? Now, what Prometheus does is it goes at a specified frequency, it goes to each server and collects all those metrics and stores them locally on Prometheus. It has a time series database. And then Grafana goes and grabs those metrics and displays them in the nice dashboard here. Now, what I can do is, let's see, let's look at the presentation if at all I missed anything. I talked about the architecture, I talked about the dashboards, we talked about the, let me see. That is my GitHub page where we publish this project. So look at the GitHub page, we have other projects published. Let me walk through a little bit on the Prometheus configuration, how it looks like in the background, and also the shell script we talked about. Okay, so we'll do a very quick walk down on all the steps here. So this is the folder where we have all the Cassandra YAML files, right? Now this is the sample file which comes with Cassandra software, and you can read through that to understand how Cassandra can publish the metrics without using JMX concept. So we are not touching JMX in this. Now this is the metrics reporter we have configured for our cluster or each node. By just looking at the top few lines, what we are telling is Cassandra every 900 seconds, it picks up all these metrics which we configured and dumps them into this output file here. This is just a plain text file which gets written every 15 minutes. Cassandra will dump metrics into this. So let me just do 20 lines out of this file. You can see one of the metrics published here. If you see, this is the system traces sessions table, and we are talking about the write latency. So good thing here is we don't have latency because if you look at that count is 0. And most likely we don't publish this to Grafana because if there is no latency, there is no point in publishing an unwanted metric. If somebody wrote Java code and published a jar file, that is where I have problem with. Like, I don't know what they're publishing into Prometheus, and I just want to make sure I have full control of what I'm publishing. So this clearly tells you this particular config file you can look at earlier tells you exactly which metrics we're publishing. Okay. Now, on each node, we also need to configure one shell script, which runs frequently, converting this text file into Prometheus format. So let's look at our cron job and figure out how we configured our Prometheus metrics. So this is the shell script, which is publishing all these metrics into a Prometheus format. Now, what do I mean by Prometheus format is, if you look at the temp folder, there is one file published called Prometheus format. Okay, so let me just show you a few lines of that. So this is how the Prometheus formatted metric looks like. So it needs a metric name, and it needs other parameters like, say, which cluster it is coming from, what is the server name, and what is this metric. Like, so for example, CPU used percentage, and you can see, for example, it is 6% used, right? Is it 6% used? Yes. And say, for example, here we have RAM available, and it shows you available in bytes. So things like this, the metrics are published in Prometheus format, and how the text file we created with Cassandra got converted to this Prometheus format is using this shell script. Now, because it is a shell script, you can basically, if you're good at shell scripting, you can actually read through the shell script and understand how this shell script works. So because we are not hiding anything, everything is open sourced here. So you can read through all of these configurations, all of these files, and understand how we are converting the metrics coming from Cassandra into Prometheus format. And also on GitHub, it is all documented on how to configure this whole setup. Right, this is how the shell script looks like. And we can quickly take a look at. So we'll go back to that architecture diagram for one more second. And you see, for example, we were looking at our Cassandra nodes. We just looked at our shell script. We also looked at the node exporter. Well, we did not look at the node exporter. What node exporter does is it publishes the metrics in this format. Every node will publish this as a URL, and then Prometheus can go grab this metrics at every given interval, whatever is configured on the Prometheus server. So we can look at the Prometheus setup right now. So if you look at Prometheus current, there should be a YAML file here, and this is the Prometheus YAML file. So if you look at more Prometheus YAML, you can see here, Prometheus has a lot of plugins. We have not configured the alert manager, but I mentioned about alert manager earlier. So you can configure this alert manager, and it will be able to send out alerts. If at all something wrong with one of the nodes is down or something, you can send an alert to your on-call team or support team. Now, you can see further here, for example, this is where we are configuring our Cassandra node metrics, node exporter metrics. What we are telling is scrape every 180 seconds, and it will go to any of this configured, any or all of this configured node exporters, and gets the metrics and publishes them or stores those metrics into Prometheus database. So once you have Prometheus running, Prometheus URL itself, like Prometheus website will look like this. So basically, you can see the Prometheus running here. You can see if at all Prometheus generated any alerts. Now we don't have any configured alerts here, so it doesn't show anything. And then you can go into status and look at the targets. And these are the targets basically we told Prometheus to go and collect metrics from. So these are all the node exporters which are publishing their metrics, each node. And you can look at, like, say, for example, you can open one of these tabs and you can look at the metrics published by that specific server. So these are all the metrics published by the server. Okay. Then, as I explained, right, all these metrics from Prometheus are being pumped into Grafana, and Grafana shows the nice dashboard. Now, my favorite dashboard is this. Like, you can see the memory usage and the CPU usage, and also this one, which is like telling me how frequently my garbage collector is running. And if at all there is a too much garbage collection happening, then your cluster might be suffering with GC pauses. So you might have to increase the allocated heap or something like that. So I think that is pretty much the rundown of the entire Prometheus Grafana journey. Entire project is published on GitHub, so you can read through how to configure and make it work for your own cluster. This is pretty much like a canned project. If you don't want to understand how it is done, you can just configure it and use it for your cluster. And if at all you want to understand in detail, everything is posted on GitHub, so all the details are available. Thank you very much. This was an exciting day. I attended several other topics today morning, and every speaker was amazing, and they brought a lot of insights into Cassandra. If you're already working on Cassandra, I hope you learned a lot today. If you are new to Cassandra, then I hope to see you on the follow-up sessions. Thank you very much.